Okay, very good morning, everyone, and welcome to yet another HSMA training day. So, beginning of your second week of HSMA training. Just thinking about what we did last week. So, obviously, on the first day, last Tuesday, we had spent the morning talking about operational research and data science, and particularly around some of the sort of wider considerations that you need to think about whenever you're undertaking a modeling or data science kind of project. And in the afternoon, we introduced you to programming, the principles of programming, rather than the sort of the hands-on stuff itself. But hopefully some of those principles got you sort of, particularly if you're new to coding, got you a little bit of insight into how coding works and some of the sort of the main considerations that you need to make whenever you're coding, and to think in a coding kind of way. And certainly when I looked at some of the work you were doing in your groups last week, that became apparent. You were thinking how to structure things in a sort of coding kind of way. So that was really good to see. But today and for the next 3 weeks, we're going to be doing hands-on coding. So I'm going to be taking those sort of first principles that I showed you and actually showing you how to do this hands-on in Python. So some of you I know have dabbled a little bit in Python, some of you haven't, but have got a bit of experience in other languages, and some of you haven't got any experience in coding at all, and all of that is fine. So don't worry, we know there's a skill mix. We're going to ease you in gently. The other key thing to say about all of this is that in no way in 3 6-hour sessions am I going to teach you all of Python. That's completely impossible. So this should be seen as a kind of starting block for you. Anything that we sort of teach you here, so today we're going to be covering a lot of the basics, and then there's key stuff that we're going to teach you, and this is really foundational sort of Python, and we'll go into object-oriented programming in the next couple of weeks as well, and things like functions and something called generator functions, which is something you need to SymPy, but there's very specific things that we'll cover. There's no way we can teach everything, and you should be, as new data scientists, using essentially search engines such as Google to look things up. There's no way we can teach. I don't know everything about Python, and Google is your friend very much for any language. As with any language as well, be it if you're learning French or something like that. As with anything like that, practice makes perfect, and it really is very important to practice the skills that you learn today. So obviously you're throughout these sessions you're going to have lots of opportunities to undertake little exercises, etc., to test out your skills and put to use what I've just taught you. But that won't be enough. You'll need to go away and do this. And more than anything else in the course, you will need to practice. Just keep writing code regularly. Even silly little bits of code, just make stuff up. Keep writing code, because you will forget it very quickly. You need to keep practicing and doing it regularly, and you'll find if you do that, that this will come to you much more easily. And obviously everything else that we teach you in the course, most of it's based in Python, not all of it, and you'll find it much easier to get a handle on those concepts and how to use these packages if you're used to using the Python basics. So do keep practicing. I know last year a couple of the peer support groups kind of got together and shared some of the stuff they were doing, and that's all great, but just keep practicing and keep coding silly little things, particularly if you're new to coding. But even if you're not, and you're just new to Python, then it's well worth. I speak from experience. You will forget things very quickly. I learned Java many years ago, and took a bit of a break from using it, and then went back to it and could barely remember anything. Some could argue that's a good thing in the case of Java, but never mind. Okay, so let's make a start. So we're going to be teaching you Python. And Python is indeed named after Monty Python, which is already a good reason to consider it's a good language. But why Python specifically? Well, Python is now the most widely used programming language in the world, which is quite an achievement for what is a relatively new language. Python is very easy to use. and it has extensive libraries of code where people have already written lots of stuff that is really useful, particularly things like for machine learning, as you'll see later in the course, really useful for that kind of stuff. And it allows us to get really quick results. You saw a little bit of that on Thursday, where you were able to interact live with Python and interrogate its variables and sort of dynamically do things. That's a really nice feature of Python, and it's the reason it's so popular for scientific purposes. And that means you can build and test iteratively, so you can gradually build things up. So it's really useful for stuff like that. Now, Python isn't as fast as things like C, which is sort of closer to the metal, and a lot of Python stuff underneath is actually built in C. But it is much more friendly, and a lot of people consider the speed deficiency to be worth it for the friendliness and the interactive nature, and also the libraries that are used. There's a lot of advantages of using Python, particularly for what you do. So there's a tradition in computer science. The very first program anyone should write in a programming language is known as the Hello World program, and it's basically one that just writes the words "Hello World" to the screen. Now, back in the 80s, back in my day when I was young and learning coding and what these computer things were for the first time, and in fact most of us were, actually getting a machine to put some words onto your television set was mind-blowing. And once you sort of sampled the delights of interacting with a television script, that was crazy. So I appreciate maybe it's not quite as exciting these days, when we're all far more used to this kind of stuff. Nonetheless, it is a tradition. It's a fine tradition, and it's one that we will keep hold of today. Now, you've already, those of you who are here on Thursday for the Spider and Jupyter Lab and Colab session, will have already actually done this by writing a little hello world command in the exercise. But we're just going to talk about it a little bit more detail, because I just basically said write this and I didn't really explain it. So to print some information, some text to the screen, we use something called the print function. And the print function is basically just a function that displays text onto your screen, your output device. And the input that we pass into that function is whatever we want to print. So very simple function. Remember, we talked about functions last time. We said that essentially they take either 0 to many inputs and then there's some sort of output. So here, print function takes it as an input, and there are optional additional inputs you will see later in the course. The primary input is what you want it to print. The computer will then take the print instruction and say, okay, I need to display that text onto the screen, and that then becomes your output. So I don't want you to do this right now. I will do it just to show you, because you already had a little bit of practice doing this the other day anyway, and you will also get practice in the exercise shortly. But if I just open up my Spider window, if I can run it, there we are. So I'm just going to type in the words print hello world. I've got an exclamation mark because I'm that excited about it, and then I'm going to run it. And excitingly, we've got the words "Hello World" come back to me. This is cutting edge stuff. And as you saw on Thursday, of course, I could also, one of the beauties of Python is I don't just have to write everything in here. If I want to write stuff and test stuff dynamically, I can have instructions that carry out immediately over here. So I could have done the same thing over here and run that, and then immediately that instruction is carried out. Okay, so really simple function just to start you off there. So that's the hello world function, and you'll be using a lot, particularly during the sort of initial phases of your coding journey. You'll be using things like print quite a lot. As time goes on, you'll probably use it a little less. But,
hello, is it me you're looking for?
Hello, I think somebody's. Can you make sure you're on mute? Okay, brilliant, thank you. Lovely voice. But okay, so let's talk about variables. So do you remember last week in the Tuesday afternoon session, we talked about what variables were, and we said that effectively they are little boxes. So they're boxes that contain some information, and they've got a label which basically explains what the information contains. So we might have a box that says name, and then inside is the actual name that we're storing. Now, in a lot of programming languages, we need to create a variable by declaring it. So we basically say, I want a new variable and I want to call it this, and it's this type. So you remember we talked about types. We said there's things like integers, which are whole numbers. We can have strings, which are text, etc. But a lot of the programming languages, you have to do that up front. And Python variables are dynamic, so we don't need to do that. So they're not strongly typed, and I'll come on to what that means in a moment. So basically, whenever we want to create a variable, we essentially do it on the fly. So we simply give a name that we haven't used, or if we have used that name before, then we'll overwrite whatever was in it before. And then we give it the value. We assign the value that we want to put into that variable, and Python will automatically then say, oh, okay, so you want a variable with that name and storing that value. And we use the equals operator for assignment. Now, this is a really important thing that, particularly if you're not used to coding, this might seem a little odd at first. There's a number of things throughout this course that may seem a bit odd if you're new to coding. So we use the equals operator, not to say, are these two things the same, but to say, put this value into this thing called this. Okay, so in the case of a variable, so let's have a look at an example here. We're saying, I want a variable called age, and in that variable, I want to store the value 52. So I use the equals operator, the assignment operator, to do that. So what Python will do is it'll say, okay, in the variable age, I will store the value 52. Now, if this is the first time Python has heard of the variable age, then it'll just automatically create one. A lot of programming languages, it would say, I don't know what age is. You'll have to tell me first. Python won't. Python will say, okay, right, that's a variable value, and I've worked out that it must be an integer because you've given me an integer value. And so Python will set that up. If you've already got a variable called age, then it'll overwrite it with whatever's here. Now, that also means that if you then wrote as the next statement, age equals Bob as a string, it will then change that variable type. So it will move from being an integer to a string. It's like, okay, you now want that to be a string. Now, that can be really useful. And obviously, part of the benefit of Python is that it's dynamic. Just be mindful of that. So some people hate that kind of thing, and like having sort of static fixed variable types that you declare, and if you want it to be something else, then you have to declare that. Part of the reason is because then if you accidentally store a string in something that you were hoping should be an integer, obviously you may not notice, because, or at least initially, because Python is fine with that. Python will just change the variable type dynamically. So just be aware of that. But certainly if you're newer to coding, you'll probably notice it less. But if you're used to coding in languages where you've got strong variable types, that will be more of an issue for you. So just be aware of that. So obviously here we've got age set up as a variable that will be of type integer. And here we've got a variable called name, which we're assigning a string type variable. Now, whenever we name our variables, you probably very quickly get to the position where you want to name a variable or whatever else, a function maybe, with more than one word. Okay, and that's going to be a common thing. It's very rare that you're just going to have single word descriptions of things. The problem is, in a programming language, we can't just put a space, because a space indicates a separation between various instructions or values. So it thinks you've moved on to the next thing. And we can't use quotation marks because that's reserved for strings. So we have to have some way in which we want to, if we want to put multiple words into the name of something like a variable, to be able to write that. And there are two main conventions for doing that. One of them is known as Camelcase, and the other as snake case. Now, Camelcase is the one I used to use a lot when I was coding Java. Camelcase is where you basically, if you need to put more than one word in a variable name, let's say, then you put them all together and you just start each new word with a capital letter, so people can see where each new word begins, except for the very first letter, which must be lowercase, and we'll come on to later in the course why that must be so. But essentially, you're using this sort of camel notation. So it's like the humps of a camel that you're seeing these capital letter bumps that allow you to indicate where a new word begins. And I used to use Camelcase a lot. These days, I tend to use this exclusively, which is Snakecase, which is basically where we put each new word separated by an underscore. So essentially, you're putting in the space, but rather than an actual space which you can't use, you're putting in this underscore, using that as your fake space. I tend to prefer that quite significantly because the underscore is a good replacement for a space, and I think it makes it a bit clearer to read, particularly if you've got variable names that have 4 or 5 words or more. Then actually Camelcase can look a bit messy, can be a little bit harder to read, whereas something like this I think is easier. Having said that, please use whichever one you prefer. If you much prefer using Camelcase, then do so. That's not a problem at all. But you should be using one of these conventions. Okay, so we talked about variables. Let's remind ourselves what the main variable types are. These, by no means are all of them, but these are some of the key ones that you'll use, at least initially. And let's see how we would use them in Python. So in terms of numbers, 2 of the key ones that you'll use are ints. These are integer numbers or whole numbers, so numbers like 27. And floats, which are floating point numbers, which are basically numbers with up to 15 decimal places. There are different variable types when you need even more precision. It's highly unlikely anything you do in this course or for your project will need that. But just be aware, if you did need that level of precision, there are other number types for that. Then we've got strings. So strings are basically sequences of characters. And so we might have a string that says the word apple, or it might be multiple words. Sentence, Dan is the best teacher. That's probably a string that you'll need to use quite often. And in Python, we denote the value of a string using either single or double quotation marks. You can use either. It's completely interchangeable in Python. My only advice would be to be consistent. And that might mean that you use double quotation marks for certain things and single quotation marks for other types of text value. That's also fine as long as you're consistent, and that's basically just to make sure that Python won't have an issue if you're not consistent. But you should always be thinking about making this as friendly as possible for other people who are trying to read your code. So it just keeps help. All these little things help keep things tidy and easy to read. I tend to prefer double quotation marks for most string values, but again, entirely up to you. Probably goes back to my basic days where it had to be double quotations. Then we've got these really useful things called lists. You'll be using these a lot. Lists, remember, are ordered sequences of items. So these are a collection of things that where the order matters. The order of things matter. So if we refer to the second element of a list, we know which element that is. And in Python, we denote a list using square brackets. So if we use this notation, we then put our values that we want to put into the list in those square brackets. So here I've got a list where I've got the values 1, 5, 3, the string Matthew, and the Boolean true, and the order will matter. So I can say what's the third element of my list, and it'll be value 3. So that matters in a list. Now, list you will use a heck of a lot during your Python coding. We've got sets as well. Sets are like lists, but different in that they are unordered, so the order doesn't matter. So they can be in any order, and they are unique. So they only contain unique items. You can't have duplicate values within a set, and that's why the order doesn't matter, because you've only got unique values. And we use sets using the curly brackets notation here. So I've got a set here with the values 1, 2, 3, 4, and 5, but you can see the order doesn't matter. I've put because they're all unique values, so I put them in as 4, 1, 3, 5, 2. But that is the set of values 1 to 5. You will use sets for some things in this course, but not quite so much. And that probably goes for your more general Python stuff as well. But they are useful, particularly when we come on to use a package called Spacey in the natural language processing. When we do something called opening up the training pipeline, they're very useful for that. We've also got things called dictionaries. Now, dictionaries are a bit more useful for the sort of things you'll be doing. You'll be using dictionaries quite a bit more often. Dictionaries are basically unordered collections of key value pairs. So let's just unpick that a bit. That basically means that you store a value against a value you would look up. So you might store the value Dan against the value name, or, you know, I probably should have updated this, but value 39 against age, for example. So you can look up, I want to grab the age value, and it'll give back the value associated with it, like a dictionary. You're looking something up, you're looking up a word and then getting the definition of that word. Again, the order doesn't matter in a dictionary because you're looking up. It doesn't. You don't refer to things as the third element of the dictionary. You say what's the value associated against this key name. And again, we use curly brackets notation in Python to denote dictionaries, but we use this format of x colon y. So this is the key. Sorry, this is the this is the key. This is the colon, and this is the value. So I look up this value, and Python will return this value here. Okay, so this is the key you look up. This is the, think about it in terms of dictionary. This is the word you're looking up, and this is the definition. Okay, so you use that structure where you have your key colon value as a pair, and each pair is separated by a comma. So you use those quite a lot, and you'll get a bit of practice using those. Quite a bit of practice in the course. Then we've got things called tuples. Tuples can seem quite useless initially, but actually they're quite useful for some of the stuff you'll do. But you'll see when we use them why they're useful. So tuples are basically ordered like a list, but they are immutable. That means that once you've created, you can't change them in any way. So we actually use the normal brackets for denoting a tuple, unlike a list, which would be square brackets or curly brackets with sets and dictionaries. Tuples use normal brackets. And we specify it in the same way we would for a list, but once you've created it, you can't change it. So a list, you can say, actually add this value to the list, or change the value that's the third one in. You can't do that with a tuple. Once you've set it up, that's your tuple. And you can destroy it or overwrite it, but you can't change that tuple itself. So you may think, why is that useful? Again, a little later in the course, you'll see examples of where these can be quite useful. And then we've also got Booleans. Booleans are enormously useful. You'll be using all these all the time. Remember, Booleans are values which are either true or false. And so they're really useful for things like conditional logic, where you can say, if this is true, then do this, or make this check, and then return me the value. And then if that is true or false, then do this. Okay, so that's variables. And some of the variable types, the most common variable types that you'll be looking at in Python. Now, just going back to strings a minute, there's a really nice newer feature in Python, which is available from, as long as you've got Python 3.6 onwards installed, which you should all have if you've installed all this stuff recently for the course, called f-strings. And f-strings are basically formatted string literals. And these are basically strings where we can include formatting within the string to define where we want some dynamic text. So we often want to do that where we basically want to insert the value of a variable into a string of text. So for example, if I wanted to put the text onto the screen, her name is whatever, I can't hard code that if I'm depending on the value of a variable. So what I can do is I can use an f string to say, print these words that are fixed, and then print these words that are stored in this variable. And it allows us to create that dynamic string. Now, to use an f string in Python, it's very easy. All we have to do is put the letter f ahead of the quotation marks at the start of our string. that then turns it into an F string. And then we basically use these curly brackets to denote where we want to include a variable value. And within those curly brackets, we put the name of the variable. So in this example here, we've got an F string that will print the words, the patient lives in, and then whatever words are pulled out here will be whatever is stored in the variable hometown. So it won't, the string is actually storing this bit, which is hard coded, and then this bit where it's going to grab whatever value is stored in the variable hometown. So let's go back to our little mini program, our Hello World program. I'm going to amend this slightly now. So I'm going to have a variable that I'm going to call my name. I'm going to store the string Dan in that variable. And then rather than hard code the message print hello Dan, I'm going to say print, helps if I do an F string. So I'm going to use the letter F, then I'm going to use the quotation marks. I've now got an F string, and I'm going to put the words hello, and rather than hard code the word Dan, I'm going to get it to grab it from that variable value. So I'm going to use the curly brackets. I'm going to give the variable value, variable name as my name. So now when I run this, so what I've done here, I've stored the value Dan, the string value Dan in a new variable called my name. And then I've told Python to print this F string, which contains the hard-coded text hello, followed by whatever value is stored in my name. And so if I run that, I get the words hello Dan, and then I can change this to whatever I like. So I put Julie, there you go, hello Julie, and it's really useful. F strings are enormously useful, particularly when you're building simulation models or anything machine learning, to have that sort of dynamic response. So they're really nice, useful feature within newer versions of Python. But you can also do lots of other fancy stuff in with F strings as well. So more than just put the curly brackets around the name of a variable. So you can put in instructions. So you could here, for example, say the answer is, and then have an instruction, that calculation that it has to make, and it'll then output the number 4. So it'll run that calculation and then use that, the output of that to do that. Here I've got a very long floating point number with lots of decimal places, and I'm using an F string here to say I want you to give me that value, but I only want it to 2 decimal places. And the way we do that, we can do that within an F string, within the curly brackets. We give the name of the variable, then we use a colon, and then we use a full stop decimal place indicator, and then we use 2F. So that basically means give this variable value as a floating point number, that's the F, with a precision of 2 decimal places. That is enormously useful, and you'll find that particularly your simulation outputs, obviously you're going to have very high levels of precision that are going to be meaningless. You're not going to want to print out to the user the average time in the system was 2.641729165 minutes. That's going to be nothing. It's 2.5 minutes at best. Probably you'd round it up to 3. Depending on what you're doing. So you don't need that level of precision. So using these F strings to specify your precision is really useful. And of course, I can use that to also split across multiple lines. So maybe you have a very long string that you want to print out, and you can write long strings using F strings. The way you do that is you use your F string notation as normal, and then you separate F strings using commas. So I can just say, okay, I've run out of space there, because remember, you don't want to go over the line. Don't go over the line. Put a comma in, and then put another F string, and then when you print that out, it'll continue as per normal. F strings will automatically put in a space. Just be aware of that. By default, you can change that, but they will automatically put in a space. So here, I haven't put in a space after span or before multiple. It'll automatically do that for me. So those are F strings. You've got lots of practice using those today, and also later in the course. I'll just also make you aware of the older method as well, which is equally valid. And you may have some experience using this method. If you prefer that, that's absolutely fine. But it's also important to show you this because a lot of you will be encountering other code, and because the F strings are relatively new in programming terms, you'll see a lot of people still using the old methods. So some of the content that I show you later in the course from my colleague Mike, for example, he still uses the old methods. So you'll see that kind of thing. And so it's worth being aware of what the old method looks like too. And basically here, if we wanted to put hello and then the name, a value from a variable, what we do is we put in the print command the string hello, followed by a comma, and then the name of the variable outside of that string. And you can join these things together. So you can put in, I want to print the words happy birthday, close my quotation marks, open, put in a comma, then whatever value is stored in my name, which appears Dan, and then open the quotation marks for the next bit of the string, close them, put in the next variable value you want to put in. So you can see how they're constructed, but you can also see how they get a bit messy quite quickly, particularly if you're putting in lots of variable values, and why F strings are so much nicer for that kind of thing. We also put in this little set operation operator here. That basically just means, so if you've got sep equals quotation, that means don't put in additional spaces. So by default, unlike like F strings, it will automatically put spaces in between. So if I hadn't put that option in, you'd actually got happy birthday space space, then my name space space, you are a comma, you are, etc. So it's worth bearing in mind, if you do use this method, you have to either do that or you have to take out the spaces in the way you assemble F string. And that's kind of why I prefer the F string method, because although it does that, it's a much more natural way of writing the strings, and so it's less problematic. Okay, so thinking now in terms of user input, because it's not just outputs that we want to worry about, it's also we need to get information from the user. And in fact, for any meaningful program, we're probably going to want to ask the user to do something in order to continue with that program. Now, fortunately, in Python, it's really easy to get input from the user. That's not always the case in programming languages. I still remember how horrendous Java was, and probably still is, just to get, certainly when I learned Java, it used to take 3 lines of code just to get an input from the user. It's not very well designed for that kind of thing. Python, really easy to get some input from the user. We basically just tell Python that we need an input. We give it any message that we want to display to the user. Hopefully that's normally telling them what they need to input. And also the name of the variable in which we want to store the input. So as an example, let's say we want to ask the user how old they are and then store that in a variable called age. This is the structure we would use. This is the variable that we're going to store it in. Well, then we use the assignment operator here. So we say the value, the variable age, I want you to store in the variable age this value. And the way you're going to get this value is by getting an input. So we're going to call the input function, which tells Python it's going to need to go to the user and ask them something, and ask them to input this value. And I'm going to give that input function in the message, how old are you? And then when you run that, Python will stop, it'll go to the user and display this message. The user will then be prompted to type something in, and then whatever they type in will get stored in this variable value here in age. Now, this particular example that I've given there might be a problem with that. Does anybody know what that might be?
Below the string?
Yes, exactly so. So basically, by default, whenever we grab an input from a user, the inputs are read in as strings. So sequences of characters, or text, if you like. Now, for some things, that's absolutely fine. We may want it as a string. But for something like age, which is something we're probably going to be dealing with numerically, we probably want to work with that input as a number. So in order to do that, we're going to need to convert the input that will come in as a string type and cast it as an integer. So casting is the process by which we basically transform one variable type into another. And it's a bit like, sort of magic, I suppose. So you string, you are now an integer. So there's two ways we can do that. We could do that separately. We could spell that out. So we could read in the input first. That will then store a string value against age, and then we could cast the string value as an integer. And the way we do that is we put in the type that we want to turn it into, and then in the brackets we put in the name of the variable that we're casting. So if we put int, it means we want to turn it into an integer, and then inside the brackets we put the name of the variable that we want to turn into an integer. So in this case, age. So you could do that, or you could do it if you wanted to all on the same line. So here we're using the same commands we did before, except we're also casting the result as an integer before we store it in age. So this will run the input command. It'll ask the user how old they are, and read that in as a string, but then the result, the output of that input function will then be cast as an integer. So we turn from a string into an integer before it gets stored in age. Doesn't matter, you can do it whichever way you prefer, but don't forget to do that if you are reading in user inputs that are going to need to be dealt with as numbers. Okay, so enough talking from me for a minute. I just want you to take a quick 10 minutes just to have a practice of what you've learned so far. Very quick and easy task that I want you to do. I'm going to put you in your breakout rooms. If other people are stuck, do make sure you help them. What I want you to do using what you've learned so far, just write a very simple program that asks the user for their name, then asks them for their age before printing the message, happy birthday, whatever their name is, you are, whatever their age is today. Now, you've got 10 minutes to do that. Some of you will do that incredibly quickly, so feel free to have a quick stretch of your legs if you do, but do make sure to help each other if anybody is stuck. Okay, so we'll come back just after 1:15, and I will open up the breakout rooms now. Yeah, hopefully you got a chance just to try out that simple little input and print thing. So I'm just going to share my screen just to show you how you would do that. Share. Okay, so if I go into my spider, so basically what I want to do, set up a variable called name, and I'm going to store the no, sorry, I'm not going to store the variable. So we want basically the user to input these variable values. So I'm going to put in an input statement here. I'm going to say, what is your name as the message? I always put, I mean, this is totally up to you. I always put a little colon and a space there so that it becomes clear where they're going to be typing. That's entirely optional. And now I could do the same thing with age. And I'll say, what is your age? But, and actually for the purposes of this, that would work absolutely fine. But really, if I'm reading in an age, I'm probably going to want to deal with it later down the line as a number in some way. So I'm going to cast it as an integer. So I'm going to cast here, int. I'm going to put the what's int around that, wrap that in brackets, and now what that'll do is it'll read in the value from whatever they type in when you say, what is your age? But it'll then cast that as an integer before storing in age. And if I just run that, you should, and go over to the, oh, it is running. I couldn't see it. So if I run that, it'll say, what is your name? So I look down, what is your age? 40. And then you can see once that program's run, the variable explorer up here, ignore the my name, that's from the previous code. So you can see it's stored name as a string because we didn't do anything with that. That's right, we do want to deal with that as a string, but it's stored age as an integer, the number 40, because we've cast it from an integer, sorry, from a string to an integer. If I take that out and run it again, and type in the inputs again, you'll see it remains as a string if I don't do that. So it's always worth making sure that you're aware of what values that you're reading in and how you're going to want to use those variables in the future. So once I've got those inputs, I can use an F string here, and I can print out a little message. I'll say, hello, name, you are age today. If I run that, once again, type these numbers in. Hello, Dan, you are 40 today. Okay, so really useful little little use of F strings there. And you'll get lots of practice doing stuff like this, particularly in the next exercise as well, which we'll come to in a moment. Any questions about any of that?
I just have I think there's an echo, so I can hear myself, but I'm just going to power through it.
Okay,
in the GitHub files, there's a Python program workbooks, and there's the IPYNB. I'm not quite sure how to open those, because every time I try, it just opens it as a notepad file, and it doesn't look like what I think it's supposed to look like.
That's for the next exercise, so we haven't come on to that yet. Were you here on the for the training on Thursday, last Thursday?
I watched the recording, and it was through the Jupyter Lab thing. I wasn't sure how to work it.
Oh, okay. So you can either open those files within Jupyter Lab. So all you should need to do is go into Anaconda Navigator and then open Jupyter Lab and then open that file, the IPyNB, or you can just upload it to Google Colab, as I showed you in the video. So you can just go onto Google Colab and then import that.
Okay,
so
great.
You can do either.
Thank you.
So let's move on. So you get more practice on this, so don't worry. Obviously, some of you, this will be your first time coding. Also, another thing, just to flag up, I saw a few of you doing it. Don't use capital letters at the start of your function names, because it won't pick them up, or your variable names either. Capital letters are reserved for very particular things that we will come on to in a week or so. So generally speaking, you should be using lowercase for everything. Okay, so just be aware of that. I know it's if you're not used to coding, it can be very odd not putting capital letters to name things, but that's the way you need to do that in code. Oh, jumped in at the start rather than the end. Okay, so I've talked quite a bit about ensuring that your code is friendly for other people, and it's a really important consideration whenever you're doing any free and open source development. In fact, it's even if you weren't doing free and open source development, you should still be making your code friendly to read, either for other people or indeed for yourself. When you come back to look at your code after a little time away and then try and work out what on earth you were doing. And that's a very common thing. So don't think it won't happen, because it will. So you need to be friendly to yourself and to others when you're writing programs. And a very good way of doing that is to use comments to comment our code. And comments are just basically a way for us to leave little notes explaining what various sections of code are doing to make it easier for other people or even yourself to follow. There's different ways in which you can include comments in Python. So we can use the hashtag symbol here. If we put that, then basically this line will then in Spider it'll turn gray, and it'll say this is a comment, or we type in whatever we want here, and none of this will be treated as code. Python will just ignore it. It's just, you can write whatever you like here. It won't be run as an instruction for the computer. You can just write narrative text that explains what's going on. If you use the hashtag notation, then when you start a new line and you want to continue your comment, because remember you don't want to go over the 80 character line, then you need to put another hashtag there to say this is also a line of comment. You don't have to put those at the start of the line. They can also go at the end of a line as well, so you can put them after a variable value 2 or instruction, whatever it may be. You can also use this format here as well to put in comments. This is the triple quotation marks. So you use 3 lots of double quotation marks here, and we put them in at the start and the end. So this is also a comment, and this, even if you go onto a new line, it'll still be a comment. and everything will be a comment until you close that comment again by putting another 3 double quotation marks in a row. Okay, so the hashtag, it basically says this line is a comment, and the triple double quotation mark notation basically says everything from this point forward until I close it again is a comment. This is actually quite useful when you want to shut off a giant block of your code. So actually something's going wrong up here. Let me just shut off this bit so it doesn't run that, and let's just deal with until I find out what's going on. I'm just going to run this bit. So it can be really useful for that as well. You can just basically comment out large blocks of your code. So also mathematical operators. Mathematical operators are very useful because usually if we're dealing with numbers in some way, we're going to want to manipulate them in some way. We want to do something with them. And very often it may be that we need to just do some very sort of common standard mathematical operations on them. So, you know, adding things together, subtracting them, multiplying them, dividing them, whatever it may be. We can do that very easily. So here we're saying a plus b. So whatever value is stored in a, add it to the value stored in b. Here we've got a minus b. That's all very simple. So these two are really straightforward. This, if you're not used to coding, is where it looks a little bit more odd. So the multiply symbol is not an X, it is the asterisk here. So we say A asterisk B means A multiplied by B. You'll get used to that very quickly once you're used to coding. And similarly for divide, we use the backslash here. So A divided by B. Then we've got modulus. Now, modulus is a really useful symbol. So this uses the percentage symbol. It's a really useful function because what it does is it says return the remainder. So take A, divide it by B, but then don't give me the result of that calculation. I want you to give me the remainder. So if A divides neatly into B, then B divides neatly into A, then the modulus value would be 0 because there's no remainder left over. But if one doesn't divide neatly into the other, then basically give me the value that it doesn't divide neatly into. Now you'll see some examples of why this is useful a little later. But bear in mind, it's a really useful little function, the modulus function. We also might want to say a to the power of b. So if you want to say, you know, a cubed, it's a to the power of 3. We'd use this double asterisk here. So that basically means when we use that, rather than multiply, it'll say raise the value in a to the power of b. So 2 to the power of 3, for example, will give us 8. There's also little shorthand notations down here. So a very common thing that you're going to want to do in programming is either to iterate or decrement, where you're basically increasing a value continuously or decreasing a value continuously. And again, you'll see examples of why that's useful. So these little shorthands are really useful. So what we could do, let's say every time we went around a for loop, we wanted to increase the value stored in A by a value of 1. We could say A equals A plus 1. In other words, overwrite the value stored in variable A with whatever is currently stored in the variable A and add 1 to it. So that'll increase it by 1 each time. But a little shorthand that's really useful for doing that is to say A plus equals 1. And that basically is shorthand for this. It says, take the value of A that was there before and add 1 to it. Similarly, if you wanted to add 5 to the value each time, you just replace that with a 5. And you can do it the other way around as well. So you can use the minus equals as a shorthand for A equals A minus whatever value. So you might be thinking at the moment, I don't know how useful this is. You will find this is enormously useful. You use this a lot, and you'll see why as time goes on. But just remember this little shorthand. And the key thing, people who are newer to this, one of the common ways I'll trip up is to put equals plus instead of plus equals, or equals minus instead of minus equals. Make sure that the plus or the minus is the first part, followed by the equals. Okay. So last week in the Principles of Programming session, we talked a lot about conditional logic, which is where we basically want our program to do something if something is true, and otherwise to do something else, or nothing. Now in Python, we can apply conditional logic using if, elif, else statements. So let's have a look at an example. So let's imagine that we've got a program, and in our program, we want to print a different message to the user, depending on whether or not someone is aged under 60 or they're 60 plus. Okay, so essentially, this is a piece of conditional logic where we need to check the value of their age, and then depending on that check and what comes back, we need to either do this thing or do that. So we could write a piece of code that did this, where we say if, and then whatever our statement, our conditional logic statement needs to be. So here we've got the statement age, and then this little symbol here means less than. So if age is less than 60. Now, a conditional logic statement will always resolve to a Boolean, okay? Because essentially what you're doing with this conditional logic is saying if, and then you're doing this little operation here, and if that is true or false, sorry, if that is true, then do this, and then otherwise, if it's false, then do this. So it must resolve to a Boolean. And I'll come back to what some of these operators are in a moment. So here we're saying if age is less than 60, then print this message, please go to room A. And then we use the else statement to say if that isn't the case, in other words, if it's false, the age is less than 60, in other words, it's 60 or more, then print this message over here. Now, notice a couple things here. So we use colons to indicate that this is the end of this, also the start of this this block of code here. So if this is true, colon, do this. Else, colon, do this. Also notice the indentations. So when you're in an IDE like Spider, it'll automatically put this in for you, but you should be aware of this, that when you type something like if age is less than 60, hit enter, it'll automatically put in an indentation. Now these indentations are basically saying this is a code block. So this block of code will be run based on this statement. So only write this if this resolves to true. Otherwise, it'll jump down here. So if we put in an age of 61, this will never get run. It'll jump down to here, and then it'll run this block of code here. I put this here as a reference. I'm not going to go through all of these now, but these are the different comparison operators that you would use in conditional logic. Key thing to say here, I said that the equal sign is used as the assignment operator in Python and in most programming languages, actually. Therefore, we need something to say where things are equal. And so in Python, we compare whether things are equal using a double equals operator. So we say if we want to see if A is actually equal to B, then we use equals equals. So A equals B would mean store the value of B in A, but A equals equals B means is A strictly equal to B. So that can take a moment to get your head around if you're new to coding in particular, because if you want to say if two things are equal, you need to remember to use the equal sign twice, because a single equals will mean an assignment. It means store the value on the right into the thing on the left. So this means to check whether A is strictly equal to B. We can also use an exclamation mark here to say turn that into a not. So this says not equal to B. So if A is not equal to B, then do this. You saw an example of the less than. You've also got the greater than symbol here. So value of here, we're saying value of A is greater than value of B. Here, value of A is less than value of B. And we can combine that with equals as well. So we can say A greater than or equal to. So if it's at least the value of B, or the opposite, less than or equal to. And we can also combine comparison statements as well. So we can say, for example, if A is strictly equal to B, and also if A is less than C. You might want to check two things at the same time. So we use the and. So this will only resolve to true if both of these statements come back as true. If that is true and that is true. we can also use the or statement, which basically says, so if we put that in an if statement, we could say, do this if that is true or that is true. So as long as one of those things is true, then do this. So and when you need both of the things to be true, or you can use you can have 3 or 4 or more, or use the or statement if you only need one of the things to be true. Now, so far we've looked at if and else. So you say do this if that's true, otherwise do this. But it might be that we have more than one condition to check, and we can use the else if or elif command in Python to do that. So let's say here we want to check if the age is under 16. If it is, then we're going to write in this message here, please go to the children's room. But then we're going to check, okay, so they're not less than 16. So if you've got here, then this was false. Okay, so Python is going to look at this statement first. It's going to say, well, I need to check the value of age. Is it less than 16? If it is, then it'll run this statement and then it'll exit this if statement. But if it's not true, then it'll jump to the next thing. It'll skip this code block and it'll move on to the next one. And so here we're going to say, okay, you're not less than 16, but are you less than 60? And we don't need to put here, are you less than 60 and 16 or more? Because of course, up here, we've identified they must be 16 or more. Otherwise, you wouldn't have got here because it would have gone into this bit. If they were less than 16, oops, if they were less than 16, then this piece of code would have been written, would have been run here. So this is quite a nice way. It means we don't have to replicate that. We know they're not less than 16. We know they must be at least 16 if they've got to this bit. So here, then we know they're between 16 and 60. And if that's not true, then they must be over 60. And so we can print this message over here. Okay, so that was a bit of a whistle-stop tour of some of the core concepts in mathematical operators and conditional logic, and also how you deal with kind of variables and getting inputs from the user and displaying outputs to the user. So I now want you to have a practice of everything we've learned so far. So looking at how we print things to the display, how we grab inputs from the users to get a bit more practice on that, how we deal with variables and how we cast variables using the mathematical operators and also conditional logic. So I want you to switch to Jupyter Lab. Now you don't have to, I know some of you got issues using Jupyter Lab. If that's the case, remember what I showed you on Thursday, that any Jupyter notebook you can open in Colab. You can just go to Colab and click on the import notebook from your own hard drive and just upload that notebook, and it'll open in Colab, and you can do it that way. You can even, if you want, import it directly by giving the GitHub URL for that lab, but you've probably all downloaded that anyway. So use either Jupyter Lab or Google Colab, whatever you prefer. I want you to spend the next 35 minutes or so, and also make sure you take a bit of a break in there as well. So we'll come back in about 40 minutes or so. In fact, let's give you a little bit longer because I've been talking for quite a while. So we'll come back about 20 past 11. I want you to work through that first workbook, the notebook called Python Prog Workbook 1.ipynb. Remember, you can test. So basically, let me switch over to it for you so you can see it. So it's this workbook here. So it's going to ask you to do 4 tasks. In each task, you should write your answer in the code blocks code cell here. Remember, you can test if that works by pushing Control and Enter. So let me just type in a simple piece of code here. This isn't the answer, by the way. If I push Control and Enter, you can see that runs that piece of code. Okay, so write your answer there, test to make sure it's working. Do that for all of these things. I would work through and help each other as a group. Make sure you're all doing this individually, but do help each other as well. Have a look back through the notes as well. Task 4 is a little bit harder, so you may want to think about that as a group as well. So just be aware of that. But have a go at doing these things. Refer back to your notes. Everything to answer this is all in the notes that I've covered this morning, and just have a think about how you would break these things down to run these little blocks of code. So we'll come back at 20 past. Make sure you take a break in there as well, and I will then go through the solutions. Okay, have fun. I'll open up the breakout rooms now. Okay, hello everyone. Welcome back. Hope you managed to have a go at that and take a little break as well. So I'm just going to very quickly go through the solutions for that. Certainly jumping around, it looked like a lot of people managed to get on really well with that and how to go at the last bit with some nice creative solutions as well. There's certainly more than one solution. So let me share my screen. Okay, so I got to the solutions. The solutions files will be shared with you as well. So that'll all be shared after the session. So you can look at this in your own time. So task 1 was to write a simple calculator that asks the user to input 2 numbers, then adds them together and displays the results to the user. So here I store in a value, a variable called A. I use an input statement, ask the user to please enter their first number, and then I cast that as an integer. And then I do the same down here for the second number, which I'm just storing in a variable value called B. Then I add those 2 numbers together, and I store that in a variable called result. So now whatever 2 numbers are added together, and then I use a print with an F string to say the result is whatever. So let's run that. Put in my first number is 3, the second number is 5, the result is 8. So that's all good. That's working nicely. Then on the second one,
sorry, Dan, why did you F string that?
Why did I F string it?
Why?
Because I'm putting in the result of whatever the result is here. So I'm performing the calculation A plus B, and then I am storing that in the variable called result, and then I'm putting it down here. Obviously, I don't have to use F strings. I could have done it the old method as well, but you could also have done this like that. So you could have done it straight down here. But if you notice on the next one, it asks you to store, make sure you've got the value of this calculation stored there. So, so yeah, on the second one, we're going to now check the result of our calculation up here. And then if the result is more, at least a million, so greater than or equal to 1 million, then I'm going to print this message. Wow, that's a big calculation. So obviously I only had the result of 8. So if I run that now, nothing should happen. But let me go back up and run this and just put in some big numbers. And let's run that again. And then I get this message, wow, that's a big calculation. So then for task 3, I asked you to write.
Excuse me.
Hello.
Hi, sorry. If you're putting the else, I receive error.
You put in an else statement, did you say?
Exactly, yeah.
Did you put anything after the else statement?
Just print your number is less than.
That should work. I'm not quite sure why it wouldn't. So you should be able to do something like this. Not a large number. So if I do this and then run that again, that should come up okay. Maybe worth after the session just checking your what you've got against this. Just make sure that's you haven't got something in there that's not working.
Thank you.
So task 3, you had to write some code that asks the user to input the length, width, and height of the cuboid in centimeters. If all 3 measurements are the same, the program will identify the shape of the cube. It will tell the user, and then it will calculate the volume by simply cubing one of the measurements before displaying the volume to the user. If all 3 measurements are not the same, then the program notifies the user this is a cuboid and calculates the volume of the cuboid before displaying the volume to the user. Now, of course, in both cases here, you can just say length times width times height. The reason I wanted you to do it slightly differently is just to get used to using the 2 different operators. So don't worry if you haven't done it like that. But up here, so I've got 3 variables, length, width, and height. And again, I'm going to ask the user to input these things. So I use an input statement and cast each one as an integer. Once I've got that, I'm then going to use a conditional logic. So I'm going to use an if statement to say if the length is strictly equal to the width and the length is strictly equal to the height, then all 3 must be the same. And so I will print the message, this is a cube, and I will calculate the volume in this way just by saying length and then asterisk asterisk 3, which basically means length to the power of 3. Now, again, You could say length times width times height. It'll do exactly the same thing. It was just to get you to practice using the power notation. Otherwise, so else if it's not the same, if one of these differs, so they're not all the same, then we'll print the message. This is a cuboid, and we'll calculate the volume as length times width times height. And then whatever volume comes out as, we will use a print statement down here to print the volume, and then I'll use an F string here to grab the value stored in volume to do that.
Dan,
Hello.
somebody in our group surprised me by doing if length equals width equals height.
Yep.
And it worked. Is that
Yes.
frowned upon?
No, not at all. You can do that. So, and I was going to do it for this, but I didn't want to confuse things. But yes, you can do that. You can have multiple operands in the same conditional statement. So yes, if you're doing this practically, that's probably exactly what you do. You do that, and that will work. I'll show you. There you go. See, all works. So yes, you can do that. But yeah, it was just to get you to use the and statement and not to sort of confuse you. But yes, you can combine multiple ones like that. And then task 4, so that was a little bit, just required a little bit more thinking. Some really interesting creative solutions I saw to this. So I was only after a simple sort of if, elif type code block for this, because that's all I've shown you really so far. I did see people using dictionaries, which was great, although of course one of the groups then realized I hadn't shown them how to access the value in a dictionary, which I will show you as we go on. But really good use, and indeed you probably would use something like a dictionary for this in reality. But really it was to get you to think about how to use the modulus operator, because what essentially we can think about here is we've got a number between 1 and 365. We basically have got a recurring cycle of 7 days. And so because of that, we can use the remainder to try and work out what a particular day might be. And it's probably easiest to think about it from day 8 onwards. So we know day 1 is Monday, so therefore day 7 will be Sunday. And in the second week, essentially, we begin on day 8. So if we think about if the user would input 8, we need a Monday to come back. So we need effectively to recognize it's day 1 of a new week. And so the way we can do that is by taking whatever day they input, modulus 7. So that will give the remainder after it's divided by 7. And of course, if we divide 8 by 7, we get a remainder of 1. If we divide 9 by 7, we'll get a remainder of 2, 10 by 7, a remainder of 3, etc., until you get to an exact multiple of 7. So if we put in 7 or 14, there'll be no remainder because it divides equally, and so we'll get a value of 0. And so we know that's our Sunday. And so that will then work for any number that is then put into the user. And we use a simple if, elif, else code block to identify that. As I say, there's lots of cleverer ways you can do it, but that was just what I wanted you to think about using the modulus, which I think you all picked up on from what I could see. I also put down here a little else statement to say it should never get to this. But if something does get down here, then it's going to print that something's gone wrong. And we'll come on to a little bit about error handling a bit later in the course. Okay, so let's move on. And let's talk about loops. So you remember from last week's session, we talked a little bit about loops, and we said that very often we might need to do the same thing in a computer program a number of times. And there's 2 different kinds of way in which we might want to do that. So it might be that we need to do the same thing for a given number of iterations. So I need to do this thing 10 times. Or it might be that we need to keep on doing something whilst a certain condition is true. And we use 2 different types of loop, if you remember, to achieve that. The first one, we use a for loop, where we say we want you to do this for this number of iterations. And the second type is known as a while loop, where we say, keep doing all of this whilst this is true. So let's have a look at for loops first and see how we do them in Python. So this is an example of a for loop. So in this for loop here, I use the syntax that says for x in range 10, print the value of x. Now what this is saying is, so range 10 basically is a shortcut for saying, give me the values up to, starting at 0 and up to, but not including 10. Okay, so there's 2 important things about this. If you're not familiar with coding, these might seem a little bit unusual. The first thing is that in most programming languages, for most things, you don't start counting at 1, you start counting at 0. Computers like to start at the number 0, not the number 1. And so the first number will always be a 0. Now, there are circumstances in certain things that you'll come across, which you'll see in this course as well, where it doesn't start at 0, it actually starts at 1. But usually things start at 0. So range 10 is basically the range of values from 0 up to, but not including 10. So the range function will give all the values up to, but not including the value you put in. So in this case, that'll be the values 0 to 9. So it's 10 values, but it starts at 0. So what it's saying is here, for that range of values, those 10 values, for x, so x is each value as you go through the loop, print out that value. So what this will do is the following. It'll say count from 0 up to, but not including 10. The first thing it'll say is, what number am I up to at the moment? What is x? The first time we go around that loop, x will be 0. X is less than 10, so it'll print the number of 0, and then it'll increment x by 1. And then it'll say, what number am I up to now? What is x? Now the number is 1, x is 1, so it'll print out the number 1, and then it'll increment x by 1, and it'll keep going round until it gets up to x being the value of 10, and then it'll stop, so it won't actually print the value of 10. So it'll go around 10 times from 0 all the way up to 9. Okay, so in this for loop, it's just printing the counter, if you like. Obviously, in reality, you probably want to do something a bit more clever, but this just shows you that it's essentially going around this loop 10 times and printing this counter value. So we say use a for loop, we say for whatever value in this range. We can also set up a custom range, so we don't have to start from 0. So if I wanted to count from the numbers from 10 up to, but not including 20, so again, it's another range of 10 numbers, because we do include the first number, but not the last number. Then I can put in for range 10, 20, and that'll do exactly the same as it did before, but it'll start at number 10, and then the last number it'll print as 19, because then when it flips over to 20, it'll stop. We can also have a custom increment. So by default, if you don't specify anything, each value will go up by 1 each time, but we can set up our own increment. So here I've got a custom range. So I'd say here to start from the value 2, go up to, but don't include the value of 30. And then this third option here says to increment by a value of 2 each time. So rather than count by 1, it'll go up by 2. So it'll start with the value 2, and it'll say, what number am I up to? It's 2, print the number 2, and then that's incorrect, sorry, that should say increment x by 2. And so it'll then increase the value of 2 up to 4. So then it'll go around again, print the value of 4. So each time it's going up by 2 in this instance. And then when it gets to a value that's at least 30, then it will stop and it won't go around that loop again. We can also do the opposite. We can have a negative increment or a decrement. So we can get it to count down from something. So we could say for x in range 10, so start at the value 10, and go down to the value of 0, but don't include 0. Remember, we never hit the second value. And the increment is -1. In other words, reduce by 1 each time. So here it'll start with the value of 10. It'll print that value. Then it'll decrement, so it'll take 1 off that value. Then we get the value of 9. And then it'll go around again, print the value of 9, and it'll keep going around until it gets to the value of 0, at which point it'll stop and it won't print that. As well as going through just sort of a simple range, simple counter, we can also use a for loop to iterate through a list. So we might have a list of things here. So here I've just got a list that has some nonsense in it. So I've got the numbers of 1 and 10, the string Dan, the Boolean value true, and the string HSMA. And then rather than going through a counter, I can go tell it to the for loop to go through each element in this list. So I can say for element in my list. So rather than a range, I'm giving it the list. So rather than going through a list of numbers, it'll now go through each of the elements in this list that I specify, and I'll just tell it to print out the element. So the first time, it'll start at the first element of the list, It'll print that current value. It'll ask if there's any more elements in the list. If there is, then it'll go to the next one to print the value of 10, and Dan, true, and HSMA. And then when it runs out, it'll stop. And that can be really useful iterating through a list using a for loop. And you'll do that a lot during the course. So that's for loops. But also we've got while loops. And this is where, rather than going through a set number of times or for a set list, what we actually want to do is tell it to keep doing something whilst a certain condition is true or a certain condition is false. So let's imagine this loop here. I've set up a variable value, a Boolean value called correct, and I've set a value of false. And then I'm saying in this loop here, whilst that value is false, then do all of this stuff in this body of code. So the first thing it'll do is it'll ask the user to input type yes if Dan is the best, and then store that as a string in answer. If answer is then yes, so it's strictly equal to the text yes, then it'll print correct answer, and then it'll change correct to be true, which means that when it goes around this loop again, correct is no longer false, and so it'll exit, it won't go around again. If I type anything else other than yes in block capital letters, then it'll say, think hard and try again, and it'll go around again, and it'll keep going around because correct remains false unless this happens. Okay, so we can see how that would work. So if I type in no, it'll go around the loop again, says might, think hard, try again, etc., until we get to this piece of conditional logic being triggered, where correct is set to true, which will then exit the loop. So sometimes we want to break out of a loop mid-flow. So we might, for example, have a for loop, and we want to break out of it and not go through all of the iterations if a certain condition has been met. We could use something called the break command to do that, and the break command basically tells Python to immediately break out of that loop and continue as though it had completed the for loop, that had gone through all the iterations. So imagine this piece of code here. I've got a variable called total, which I'm going to start with a value of 0. And then I've set up a for loop here with a range of 10, so the value is 0 to 9 inclusive. And then each time it goes around, it's going to take the value of total, which starts off at 0, and it'll add x to it, so whatever value is being in the counter here, and it'll print the total. And then if the total gets more than 5, it'll break, so it'll stop. So the first time round, total is 0, and x is 0. So it'll say total is now 0 plus 0, print that, which is 0 here. Is the total greater than 5? No, it's not, so it'll go around again. Now x is 1, total is 0, so now total is 0 plus 1, so now the total is 1, we'll print that. Still less than 5, we'll go around again. This time total is 1, so if we add an x is now 2, so the total will now become 1 plus 2, which is 3, which gets printed. Still less than 5 though. We go around again. So now remember, now the total is 3 and x is now 3. So total now becomes 3 plus 3, which is 6. We print that, but now the total is greater than 5, and we call the break command. So it didn't go through 10 iterations, it only went through 4, and then we had a break command that exited the loop immediately. So the other end of the spectrum, you can, and you very often will, accidentally often write something called an infinite loop, and you will have seen last week an example of that during the spider training on Thursday, where essentially you can write a loop that never ends. And those of you who are old like me, I remember writing code back in the old days of computers, will have undoubtedly come across this and typed this sort of thing where you used to type 10 print something and then 20 go to 10, which is an example of an infinite loop. It says do this, and then the next line says and do that again, and so it'll do that, and then it'll do that again, and it'll just keep going round and round and round infinitely. And so you can, more modern examples, where in Python, where you can set up a while loop that never stops. So here I've got an example. I've set the value of x to be 3, and then I've got a while loop that says keep doing this whilst the value is at least 3. And the thing it's going to keep doing is print the value of x and then add 1 to x, which means because we're doing that, x is just going to keep going up and up. So it'll always be greater than or equal to 3. It's never going to break out of that loop. So that's an infinite loop. Or we might have this statement here where we say while true. Now, sometimes you deliberately want to create an infinite loop. And the way you, and you will see examples of that later in the course, and where you want to do that, you usually use this statement that says while true. So that basically says, whilst true is true, which is always true, because true is true. So that deliberately creates an infinite loop. So whilst true, so infinitely do this, print down is the best. So you'll never break out of that loop because it's always the case that true is true. That's a really handy thing if you want to deliberately create a while loop. Now, very often you accidentally create an infinite loop. And if that happens to you, and it will at some point, refer to the notes that we went through last week. Remember, you can just hit Control and C if you're using Spider, as long as you're in the console, you can hit the red stop button, and you can interrupt it. So it won't, unlike the old days, it won't lock up your computer until you turn it off and on again. Okay, so we've talked a little bit about for loops and while loops, and also breaking from loops. So now I want you to spend the next half an hour working through the next workbook. So this is Python Prog workbook number 2, and you're going to practice using loops. So if I just open up code, this one here. So again, you've got 4 tasks to do. The first one asks you to write a piece of code that asks the user to input a number, and then the machine will print out the times table for that number from 1 times up to including 12 times the number for whatever number's entered. Then you're going to write a piece of code that sets up a new list called HSMA trainers with these initial values, and we'll iterate through that list saying hello to each of these members. In the third task, I want you to write a piece of code that asks the user to input a number, and we'll keep asking the user to input a number until the number entered is more than 100. But if the user enters the value of 0, then the program will exit with an appropriate message. And this is one of the uses of having a while loop, an infinite while loop, is to have something where you can have like a menu system where you keep asking the user to input something until something else becomes true, and then you can break that. And then in the fourth task, again, a little bit more challenging, so do work as a group for this. Think carefully about how you're going to approach this. I want you to write a piece of code that counts up day numbers from 2 to 364 inclusive, and displays a message giving the day number every second day. And additionally, as well as the day number, every 4 days also comes up with a message, go shopping. So you want a piece of code that basically says it's day 2, and then it says it's day 4, go shopping, day 6, day 8, go shopping, etc. Okay, so think about how you do that using what you've learned so far. So I'm going to open up your breakout rooms. I'm going to give you just under 30 minutes to do that, so we'll come back at about 10 past. But have a go at this in your groups, and do remember to help each other if you get stuck. Great. Stop recording. Hello, everyone. Welcome back. So hopefully you had a good stab at this latest exercise. Had a bit of practice using loops. So I'm just going to go through the solutions quickly for you now. Again, I will share these so you can study them in more detail a bit later. Share my screen. Okay, so first thing, you had to write a piece of code that asks the user to input a number and then prints up the times table for that number from 1 up to and including 12. So here I've got an input statement that asks the number to input a number, asks the user to input a number. I cast that as an integer, and then I store that in chosen number. And then I use a for x in range 1 to 13. So remember, I don't want to start at 0. I want to start at 1. And I want to go up to and including 12. So I'm going to need to put 13 here. so that I get count from 1 to 12. And then basically I'm going to use a little F string there saying X times whatever the chosen number is, and then the result of that calculation. So if it's 1 times 2 is, and then it'll calculate what 1 times 2 is, and then it'll do the same for the next value of X. 2 times 2 is, and then 2, and it'll do the calculation 2 times 2 here. Just a really easy way that you can use a for loop and also the F string to do a little times table calculation. Then the next one, I asked you to set up a list called HSMA trainers, put in these 4 values, Dan, Tom, Sean, and Kerry. So I set up my list here using square brackets with those 4 elements. And then I'm going to iterate, rather than through a list of numbers as a counter, I'm going to iterate through each element in this list. And so I'm going to call that trainer. I could call it anything I like, but basically I'm going to call it trainer so that every time I jump through each of these elements, I can refer to it as the trainer will be the current one that I'm jumping onto. So for trainer in HSMA trainers, I'm just going to print the message hello, and then whoever that trainer is. So first time through, it'll say hello Dan, and it'll say hello Tom, then hello Sean, and then hello Kerry. So each time trainer, which is your temporary sort of counter variable, is in this case representing the value in each element of the list. And the same thing's happening up here, by the way. Essentially, you're iterating through elements of a list. It's just you don't have a predefined list. You're just saying, give me a list of the numbers 1 to 12. And so that it goes through each of those elements instead. Task 3, you have to put in some code to input a number and ask the user to keep inputting numbers until the number they entered is more than 0. But if they enter the number 0, then the program will exit with an appropriate message. Here, before I get to the while loop, I'm going to get them to input an initial number. And then whilst that number is less than or equal to 100, if the user number is exactly equal to 0, then I'm going to print the message exiting program, and I'll put in a break statement so it'll then immediately come out of this while loop. Otherwise, I'm going to ask them again to input a number. So it'll keep doing this until either the number entered is 100 or more, or you may have done it as more than 100, doesn't matter. It depends how you interpret that, or the user inputs the number 0, at which point it'll break out with this message. And then for the task 4, it's quite a short piece of code to do this, but it just needed a little bit of thought about how to do this. So write a piece of code that counts up day numbers from 2 to 364 and displays a message giving the day number every second day, and additionally the reminder to go shopping every 4 days. So I've cheated a little bit here. You may have counted in individual days. I probably wasn't very clear about that, but you only have to do something every second day. So I'm just going to count, starting from the number 2. I want it to go up to 364 and include that. So I need to put up a value of 365. So it does include 364. And I'm going to count in increments of 2. And then for each day number, it'll print the day number. But it'll also make an additional check to see if it's one of these every 4 days. And we can do that using the modulus operator again. So we can see if it's exactly divisible by 4. If it is, that means it's one of these every 4 days, and I can print the message "go shopping" in addition to that as well. Okay. Any questions about any of that?
Can we see that run to see what it prints?
Oh, this bottom one, yes, certainly. So if I run that, it says day 2, day 4, go shopping, day 6, day 8, go shopping. You may have done it in a different way, but yeah, same principle.
Thank you.
Okay, so we've only got 15 minutes to lunch, so I'm going to try and rattle through this last bit as quickly as I can. Where are we? Yep, we're here. Okay, so you've worked a little bit with lists so far, but we can also do some other useful things in lists as well. So lists are really useful ways, as I mentioned before, storing multiple items of data. And because of that, we can, there's different ways and different things that we can do in order to create and add items to a list. So here, I'm defining a new empty list, and that's quite a common thing to do. So if I want to just create a new list, but I don't want to put anything in it yet, I just give my list my name here, and use the assignment operator, and I just use, I open and close the square brackets with nothing in it, and I'll just create a blank new list. It might be that you want to create a new list and you want some elements to start with, and that's fine too. You can create it in the same way you just did for that previous exercise, where you give the list a name, and then you say what elements you're starting with in that list. Now, let's say, though, that through either of these scenarios, we may want to add an item to a list. And we can do that using the append function. This is the first time you've seen this dot notation. Basically, what this means is, whenever you see the dot, it means I want you to use the function or attribute associated with this thing. And this will make a bit more sense when we come on to object-oriented programming in a couple of weeks, and you'll see this used a lot and why you use this notation. But for now, just think about it as my list is a list. So we're using this one here. I've set up a list. I've called it my list, and I've set up these 4 elements in it. So Python can see this as a list, so it knows that it sets up a variable of type list. And because it's set up a variable of type list, it knows this now is what we call a list object, which means we can access special functions that are associated with list objects. So there are special functions that are associated with lists, and we can access those. And one of those functions is the append function, which basically means add an item to a list. So I can, because Python now knows that my list is a list, it's a variable of type list, then I can call one of the list functions, and one of them is append. So I can give the name of my list, which is my list, and I can say dot append, which is the name of one of the list functions. And as the input to that, within the brackets, I'm going to put the value that I want to add. And I may add more than one value at the same time, but here I'm just going to add a single value, and I'm going to add the value of 2. And so if I do that, and then print my list, you can see it's added the value of 2 to the end of the list. Okay, so by default, any new values will get added onto the end of the list. So we started with that list, then we called the append function, because this is a list object, so we can access special list functions, and we called the append function to add the number 2 to that list. There's also another special function that you can use for lists called extend, and extend allows us to add multiple items to a list. So basically what we do is we give it a list of things that we want to add, and it'll add all of those items onto that original list. So here I've got a list called my list, which has the numbers 1, 2, 3, 4, and 5. And then I want to, let's say I want to add the numbers 6 to 10. So I can use the extend function of my list. And this time I'm going to pass in another list with the numbers 6, 7, 8, 9, and 10. And then if I print my list, you can see it's added them all to my list. I could have done that separately. I could have set up a new list called my new list with these numbers, and then said extend my list.extend, and then put new list in the brackets. But here I've just put it in as, so I'm essentially declaring, setting up this new list here. Haven't given it a name. I've just said it's a new list, and I want you to use that to extend my list. Now, when we refer to particular items in a list, we use a square bracket notation. And in a list, we refer to an item using its index. So its place in the list. Remember, a list is ordered, so the order matters in a list. And remember also what we said earlier, that Python, as with most programming languages, we start counting from 0. And this will throw you off initially if you're not used to coding. So that means if I want to refer to the first element of the list, I give it the value of 0. Okay. So a list of length 5, the last element would be a value of 4. You need to remember, and need to get into the habit of counting, starting to count from 0. So if I've got this list here, 3, 4, 7, hello, and 2, and if I give this command, so I say print my list, and I use my square bracket notation here to give the index that I want to print. So here, if I've got an index of 2, it'll return the third value, because that has an index of 2. So the first one is an index of 0, the second one has an index of 1, and the third one has an index of 2. So it'll return the value of 7. Okay, so it just takes a little bit. You will get caught out by that if you're new to this. So just keep remembering you have to print, you have to refer to most things in Python, including list elements, list indices, by starting to count from 0. Now you can also refer to elements in a list using negative indices, and this can be quite useful. And we use a negative index so that rather than starting counting from the left, from the first element, we refer to an item based on its position from the end. And so we can say, give me the last element, or give me the second to last element, etc. Now, just to make things more confusing, everything I just said about, oh, you have to start counting from 0, if you use a negative index, you don't. You start counting from 1. So the last element would have an index of -1, which means the first element of this list, in other words, the one that is furthest away from the end, would have an element of -5. So just remember that if you're going to be using negative indices, that you do actually have to start counting from 1 in that instance. So your last element would be -1, the penultimate element would be -2, etc., etc. But they can be really useful when you need to grab something from the end in particular. As well as just giving a single index, we can look at multiple items in a list as well. So I've got my list here again, 347 hello 2. Let's say I want to print everything from the second element up to, but not including, the fourth element. So in other words, everything from 4 up to, but not including hello. So in other words, the numbers 4 and 7. Then I would say print my list. Again, I use the square bracket notation to specify the index, but here I'm going to specify a range of indices. So I specify the starting index, which in this case is 1, which means the second element. Remember, we start counting from 0, up to 3. So that's the fourth element. But remember, it doesn't include the top element, so that one won't get included. So to print the second and third elements in the list, you have to specify the range starting from an index of 1 for the second element up to an index of 3 for the fourth element, which won't get included. Now, I appreciate this can seem a bit weird at first. You will get used to this, but it just requires that sort of dual thinking of, I start counting from 0 normally, normally most of these functions do not include the top end of the range. So I need to go to the next thing. And once you get used to it, you'll find that becomes second nature. Except there'll always be other little functions that you'll see where it does include the top, just to throw you off. So I can also, as well as specifying both both elements of the range, I can also say, just give me everything up to this element. So I can remove the number that comes before the colon and say, just give me everything up to, but not including, remember, this element. So if I print my list colon 2, that'll say, give me the elements at index 0 and index 1. So that'll be 3 and 4, first and second. Because remember, the index 2, which is the third element, does not get included. Similarly, I can do it the other way around. So I can say print everything from this element onwards. So starting from here, print everything right on until the end. So in this case, I remove the top end one. I just give the bottom end of the range. So print everything from the fourth element onwards would be print my list with a number 3 followed by a colon. Because remember, the fourth element, which is hello, will have an index of 3, 0, 1, 2, 3. In that case, it'll print hello and 2. As I say, if you're new to this, you will take a while just to adjust to thinking in that way, but it will become second nature eventually. But remember, keep thinking, you start counting from 0, and usually the top element is not included in a range. So as well as adding items to a list, we can also remove items from a list as well. It would be pretty poor if we couldn't. And there's 2 different methods that are usually used for this, remove and pop. So the remove method of a list removes a specified item. So if I were to say my list.remove, I then give the value that I want to remove. So in my list 347 hello 2, I want to remove the value of hello. So remove, you give the actual value that you want to remove. And then if I print my list, you can see hello has been removed. Then if I restore the list again to its original state, so pop is the other method that you can use. So rather than with remove, you give the value. With pop, you remove an item by specifying its index. So rather than say remove the value hello, I'm going to say remove the value at index 3, which remember is the second, sorry, getting confused now, is the fourth element of the list. See, even I get confused. So mylist.pop3 will say remove the value at index 3, which is 0, 1, 2, 3. So it's this again, in both cases, we're removing the same value, the word hello. But here we specified it using using the value itself. So we say get rid of the value that has the word hello. Here we're saying get rid of whatever value is at index position 3, which is the fourth element. We can also check whether something exists within a list. And that can be really useful when we come on to do some meaningful coding to see whether something is already in a list. So let's imagine we've got our list here, my list 347 hello and 2. We can check using the in command to see whether a particular value is in that list. So here I'm going to check if the value 2 is in my list by saying if 2 in my list. So that, as with any if statement, needs to resolve to a Boolean. So 2 in my list. In is just another operator, a comparison operator that basically allows us to check whether something is true or false. So either 2 is in my list or 2 is not in my list. And if it is in my list, then I can print this little message saying it's already there. And obviously it is in that case. Now, let's say you want to copy a list to use it for something else. That's quite a common thing you may want to do. Now, it might be really tempting to copy a list by setting up our list here. And let's say I want to create my copy of my list here. And I'm going to call it rather imaginatively copy of my list. And I'll just say, OK, I'll assign my list to copy of my list. And I'll use that notation. That won't work as you think it should. What do you think will actually happen if you did that?
Just changes the name.
Not quite. Anybody else?
It's a pointer to the list.
What was that, sorry?
Creates a pointer to the list.
Yes, exactly so. So what happens if you were to write that? It'll just make another reference to the same list. It won't create a second list. It'll say, OK, I've got this list called my list. Now you've told me, sorry, go back to this one. Now you've told me that you can also refer to my list using the name copy of my list. OK, so you're kind of right when you said about the changing the name, except you can now refer to it by both. It's not technically changing the name. My list still exists as my list, but you're quite right in it changes the pointer. So we can now also, as well as referring it to as my list, we can also say copy of my list. And if I use either of those things, it'll change the same list. Now that's usually not what you want, because that means if you're creating a copy and you think you've created a copy, because you presumably want to do something different to these lists, whatever you do to one, it's the same list. You haven't created a copy. You're just creating another reference to that same list. So you'll end up making the changes to the same list. So you don't normally want to do that. In fact, there are very few situations, I would argue, where you actually want to create a new reference to the same list. So if what you actually want to do is create a copy, then what we need to do is use one of these special list functions. And this one's called the copy function. So we give our new list name, and then we use the copy function on the list that we want to copy. So in this case, my list. If I say my list.copy, I don't need to pass in any inputs. What that will do is it will create a new copy of my list, and it'll store it in copy of my list. Now we've got two lists. One is called my list, one is called copy of my list. And initially they'll be identical, but now we can work with them separately. So if I then took out the number 3 from my list, the copy of my list won't be changed, which is usually what we want from this.
Daniel, I have a question, if that's okay.
Yeah, sure.
So for the copy of my list, is it also similar for NumPy array?
I will come on to NumPy. NumPy acts a little bit differently, so I'll come on to NumPy when we get to the NumPy bit next week.
Okay, cool. Thank you.
So realise it's half 12. I've only got a couple more minutes of stuff to go through, so I'm just going to quickly go through that, and I'll still make sure you get an hour break. So a really nice feature of Python is something called list comprehension. Now, list comprehension takes a little while to get your head around, but I'd advise you do it because it's really neat and it's really useful, and it means you can write some really efficient code. So it's worth right from the off getting your head around list comprehension because it's a really useful little feature. And basically what it allows us to do is easily create a list based off another list using just a single line of code. So let's imagine an example. Let's imagine we've got a list of numbers, and basically we want to set up a second list which contains all the numbers of the first list but doubled. So let's say we've got the numbers 1, 2, 3, and 4, and 5, and we want to create another list that has those numbers doubled, so 2, 4, 6, 8, and 10. Okay. Now, one way we could do it would be to set up a list with the numbers 1, 2, 3, 4, and 5, and then a second empty list, and then we could use a for loop to go through each element in this first list, and then use the append function on list B to say, take that number from list A, multiply it by 2, and then add that to the second list. And that'll work. That'll give us the numbers 2, 4, 6, 8, and 10. But you can actually use list comprehension to do that in a single line of code. Now, obviously, it's not much of a saving here, but when you get onto more complex operations, it can be enormously more efficient. So the way we use a list comprehension is, again, we've set up a list A here of 1, 2, 3, 4, and 5. And then in list B, rather than create an empty list, I'm going to use the list notation, so the square brackets. And rather than specify the elements or give the empty list, what I'm going to do here is say, I want you to make that list using this logic. And it sometimes helps to, when you're thinking about list comprehensions, to start in the middle. So what this is saying here is for each element, which I'm just going to refer to as X in list A, give me X times 2. So what that'll do is it'll create a little for loop, and it'll go, right, first element is 1, value 1 times 2 is 2. So that's the first element in that list. And I'll immediately put it into list B. Then it'll go around, do the second element of 2, it'll double that, put it into list B, etc. So this is saying, give me X times 2 for each X in list A. So for each element here, I could have called this anything. I could have called it tomato if I wanted to, and said tomato times 2 for tomato in list A. Doesn't matter, as long as you're consistent. But here I'm just saying, give me X times 2 for X in list A. So here are the values that I want to put in the list, and here's basically how I want you to create. Okay. You'll get lots of practice doing this comprehension, and it's worth getting your head around it because it's a really neat way of being able to create lists, new lists, very, very easily. We can also create or use conditional logic in a list comprehension as well, and this is where it comes in really handy. So let's imagine we've got the list of numbers 1 to 10 here, and then we can create another list that meets only has these elements, but only those that meet a certain criterion. So what we could do, for example, let's say we've got this list here, and then we want to create a separate list that has these numbers, but only the even numbers in that list. So one method, we could set up a list here, an empty list here, and then use a for loop to go through each number in list A, and use the modulus operator to say if it divides equally by 2, so there's no remainder, then add it to our list because it's an even number. Otherwise, we don't do that. So we only add numbers that divide equally into 2. That would work fine. That wouldn't be a problem. But we can also use a list comprehension to do the same thing. So here we've got our list of numbers 1 to 10. And in list B, I'm going to use a list comprehension statement. And again, easiest to think about it from the for statement. This says for each number in list A, or for each element in list A, I've just happened to have called it num, but I've called it num here, for num in list A, for each element in list A, if num modulus 2 is strictly equal to 0, in other words, if it divides equally into 0, then give me that, give me num. So this is saying give me, list B should be made up of num for every num in list A if num modulus 2 is strictly equal to 0, so if that's even. So give me each number for each number in here, but only if it's an even number. And you can see how that's a much more efficient way of writing a new list, creating a new list very quickly and very computationally efficiently too. I think, yeah, so this is the last slide. I just want to mention about dictionaries. So we've already talked about how dictionaries are really useful to store a lookup value against an index value. Now we may want to store various information about a patient, for example, in a dictionary, so that it becomes easier to identify to what each element refers. So we might set up a dictionary, call it my patient dictionary, and I've got my key value pairs here. So my key might be something like patient ID, and the value is the ID itself, name, Bob Smith, year of birth, 1961, etc., etc. If I were to print that dictionary, then it would show me these key value pairs. So it would say, here's your key of patient ID, here's the value, here's the key of name, here's the value, etc. To grab a particular piece of information about our patient we use square bracket notation. So now I've got a dictionary set up, I could say, actually, give me their name. I want the name stored against this, the value stored against the key name. So to do that, I say my patient dictionary, and then I use square brackets, and then I give the name of the key. So in this case, it's name. But I could do the same if I wanted to grab the patient ID. I'd give patient ID here, and then it would return the value associated with that particular key. So in this case, that will return the value Bob Smith, which is what's done here. We can easily change dictionary values using the same notation as well. So I can refer to the key, so in this case, the year of birth. I can say, give me year of birth, and I want to assign that to the value 1960. So rather than 1961, I'm changing that year of birth value to 1960, and then that will change the value associated with the key year of birth. I can even add new key value pairs into this as well. So I can create a new one called month of birth, and I use the same notation. So Python is intelligent, but if it sees a key that it already recognizes, then it'll change whatever value you give it, it'll change that key to that value. But if it sees one it hasn't seen before, so we haven't given it month of birth, and that doesn't exist in the dictionary. That doesn't exist in the dictionary yet. So it'll create it in the same way it does for variables. If you talk about a variable name that it hasn't seen yet, it'll just create a new one. So here it's going to create a new key value pair, and this will be the new key name, month of birth, and this will be the new value associated with month of birth, which is the value of 6. And again, we can use the same notation to delete a key value pair that we don't need anymore. So let's say I don't need the readmission key value pair. I can use the del keyword. So I say del, and then I give the name of my dictionary and use the square bracket notation to give the name of the key that I want to delete that key value pair. So if I say del my patient dictionary readmission in square brackets, it'll remove readmission and the value associated with readmission from my dictionary. So you can refer to individual items, you can change individual items, you can add new key value pairs, and you can also delete them as well. Okay, let's stop there because it's been a long morning. So I'm still going to give you an hour, so you'll still have to, so we'll resume at 1:40 rather than 1:30. Feel free to stay on the call. I'll just pause the recording and we will resume at around 1:40. So have a stretch your legs. Basically what will happen then, you're going to come back, you're going to go straight into the next exercise. Okay, so I will open the breakout rooms in a moment so that you can just go straight back into your breakout rooms when you come back from lunch. And you're going to work through Python Prog Workbook 3. And I'll give you, provisionally, I'll give you half an hour so we can make up the 10 minutes, and I'll see where you are. If you need a bit longer, I'll just give you a bit longer. So until around 2-ish, if you need a bit longer, I'll send a message out to the groups. So go and have a stretch your legs, go and have something to eat, have a rest, Don't think about Python for the next hour. And then when you come back, you'll be in your groups and you'll be working through the workbook through. Okay, I'll stop recording. I'll open the breakout rooms ready for when you come back and see you in an hour.
Okay. Hi, everyone. Everyone back in the room, I think. I've just tried to kind of go around the breakout rooms a little bit and just mention to you, and I don't know whether I called all of you or not, but Ben's not feeling very well this afternoon. So he's here and he might be able to jump on the chat, but he's not able to speak. So I'm going to take the afternoon session, but you all will have to bear with me a little bit. Uh-oh. Already it's going down in the room. Is everyone back in the room? Hopefully. Hopefully you're all back in the room and you can see what's going on. So anyway, as I said, bear with me a little bit. So I'm going to share my screen now and we'll just go through the solutions to that problem that we've all been working on.
Alison, I think your microphone is taking input from the laptop rather than your microphone.
Do you? I'm going to try going back to my other previous one. Does that work okay? Anyone hear me? Anyone not hear me?
Well, that's worse, really.
It's worse.
Yeah, that's worse.
What's going on now? No good?
No.
All right, I'll go back to the previous one. Disaster. I had a backup plan and everything. How's that?
Yeah, that's fine.
Is that fine? Okay, great. All right. And also, can you see my screen?
Yeah.
Yeah.
Okay. All right. So working through the solutions, I did from what I saw, most people were doing pretty well. So, and we all had different ideas as well, which was sort of quite nice as well. So the first one here, you're going to enter create a list with your 5 favorite things. So start off by making an empty list, and then you're going to cycle through with a for loop, enter your favorite things. So I think most people I saw were doing something similar, and then you need to append that to this empty list created here. Okay. Pop is just removing the last item of the list, so you have to then remove the last 2 items. So pop and then pop again. So if I put my favorite things, my dog, my husband, and my kids. Okay, and my top favorite friends are sadly my dog and my husband and my son, and the others have dropped off, so that works fine. The second thing here, creating a list, input list, an empty list again, and you're going to enter randomly enter some numbers there between 10 times, enter some numbers which will be appended to the list as previously. And then the idea then is to use list comprehension to put in the numbers that are only odd and only less than 100. So less than 100, and that when they're divisible by 2, leave a remainder of 1. So that should work. Someone's just sent me a little message. Oh, I've just turned that into a mark. Sorry. And then the final one here, I'm not sure how many people got to this. Nice little chart. You've been crashed on a mysterious island. After several years of increasingly bizarre plot developments, you walk into a cave and discover mysterious writings associated with surnames. Let me just get rid of this because I can't see. With the surname of Pencord team members Chalk, Allen, Monks, Cairn, Manzi, and Harper. You decide to write a piece of Python code that stores these entries in a dictionary, which is called candidates here, which allows the user to input a number to find out the corresponding candidate surname. Using a while loop, while true, enter the candidate name. So that's going to be, let's just run it, shall we? Okay, anyone know why that happened? Oh, I don't know why that happened.
Yeah, we should put the number in, not the name.
Right. Please enter a candidate number to, so no such candidate. So it obviously needs to be able to read it from the dictionary. Monks, let's call me up. Okay, did anyone have any other solutions for doing that? No, okay. So I think that was all reasonably okay. Let me just get you back up into the room there, sorry. Okay, so I'm just going to call up the, right, where do we get to here? Okay, so these are Dan's materials now for after lunch. Can you all see this okay now?
Yeah.
Yeah, okay. So there's just this one session that we're going to be talking through, and then after this, there's another exercise. So libraries and input. Most of the time, when you build, when you're working in Python, you will be using libraries and importing libraries, which are collections of functions that have been written by other people. So it saves you having to rewrite those functions, and you're using these a lot. So they contain useful bits of code. So you're basically, somebody else has done that little bit of work for you. And we'll be learning in the next session about writing our own functions. So to use libraries, we need to import them into the program. And usually you'll start in your program, you'll start by putting in the libraries that you need to import. So we use math in the previous session, I think. And random is a library that you're going to use a lot. So the random library contains a number of functions which allow you to generate random numbers. And the reason that you might want to do that is if you're modeling stochastic systems, which we very often are. So a stochastic system allows for random variation in one or more of the inputs over time. And that's usually based in fluctuations that you'll see in historical data. So we talked about this a little bit last time as well in the when Dan was talking about building process models. So we know, for example, that a process in a normal process in the real world, people, for example, aren't arriving at exactly 3-minute intervals, or it doesn't take exactly 10 minutes to treat a patient, for example. So we need to build that stochasticity into the model, and if you don't do that, then the outputs are going to be quite seriously underestimated. So you'll find that you do use this random library quite often. And within the library, there are different distributions that are quite commonly used, and I think Dan mentioned as well that while you will try and fit a distribution to your data, it's better to use a standard distribution than to try to use a sort of custom distribution from the data you see. So some of the distributions that you might commonly see, a little bit of further information here. Yeah, okay, so this is just what I was talking about here, that you might see within the distribution that 30% of patients in the past have spent 6 minutes with the triage nurse. And there's a 30% chance that I can't read through Dan's work on the, I'm sorry, I can't read it through that quickly. I think I've really talked to this slide, really, to be honest with you. So some of the parametric distributions that you'll see that you'll most commonly be using are the exponential distribution, which is really common for inter-arrival times. So it looks like this, and you define that with one or more parameters, each of these distributions. And inter-arrival times, remember, is the period of time between arrivals of, say, arrivals of a phone call or arrivals of a patient or gadgets on a production line or whatever. So most commonly with inter-arrival times, there tends to be a lot of arrivals that occur in very short time periods, but you can also have random periods of time, random periods across in say a 24-hour period where there might be just a long distance between arrivals. So you might get, a lot of phone calls in a row, but for some reason you get a 10 or a 15-minute period where nobody calls, for example. So that can be reflected in the exponential distribution, which is quite commonly used for inter-arrival times. Something like the log normal is really common for process times. And you'll see that, for example, with patient lengths of stay, that if you define it just with a mean, it's generally, it isn't a normal distribution. Generally, the lengths of stay are more commonly hovering around this sort of shorter periods, but you very often will just get a patient who stays for a very long period of time. So the longer the period of time, the less likely that patient stays. So basically, when you're sampling for a length of stay, this might be a common distribution you'd use, and the length of stay that any entity that enters your process will sample from a distribution that looks a little bit like one of these. The triangular distribution, that is, I know in Pencord, I've used this quite a lot, to be honest, but it's not widely liked. And basically, it probably would be better if you wanted to represent something like that, to use a normal or a log normal distribution and just truncate the ends of it a little bit, because it is a bit peaky there. But this is useful when data is limited, and you might get some vague information about how long a service time takes by speaking to some staff members, for example, and you might know that on average it could take this period of time, but there could be a minimum of this and a maximum of this, and that might be all the information you have. So you might try to use this kind of distribution. And the Poisson distribution is actually, these are all continuous distributions. The Poisson distribution is a discrete distribution. So this is often used to describe arrivals. So rather than actually inter-arrival times and the time between arrivals, this would be arrival rates. So the rate of arrival might have a mean of 5, and then there's this distribution around it, which looks a little bit like a normal distribution, but is actually a discrete distribution. So when you call in the random library, like when you call in any other library, within that library, there's going to be a bunch of functions, and you call that function by using this format here, the little dot. So within random, if you use within the random library, if you use .random, then that particular function will call up a random number between 0 and 1, and we've seen that already. The randint library is calling up a whole number, and you will provide the distribution, or the range that you want to select that random integer between those numbers. And then another choice that you could use is this one, dot choice, in the random library. So you've created a list here with a list of Pencordians, and it will randomly choose from that list. So that's another function that is provided within the random library. So this is Dan's particular favorite thing. So he obviously has been coding since before he was born, and he's describing here, this is a exercise now that you're all going to go and do using the random library and some of the other materials that you've already been taught. So he obviously was a baby when he wrote this, but he created this code that randomly picked a whole number between 1 and 100, and you're given 10 chances to guess that number. Every time the user guessed a number, they'd be told either that it was too low, too high, or correct. And once you've used up all 10 chances, then you're told that you lose if you haven't guessed correctly. So what Dan would like you to do now is have a go at rerunning this program and see if you can create the program, see if you're smarter than him as a 4-year-old. So you've got 45 minutes, and we've also got a break. So this will go until about 3:25. So if we get everybody to go back into their groups now and have a go at this, you can take your break up. Probably easiest to work through this now and take the break after. And I'll just do the same thing and go around the groups and see if anybody needs any help. And if anybody, and just pop on the chat if you need me or Dan or anyone to come in. Does that work? Okay, I can't hear anything from anybody, and I've got worried now that I've just been talking to nobody.
No, you're
still
fine.
here.
Still
Just
here.
Fine.
Okay, great, thank you. All right. So I'm going to get Dan to open up the breakout rooms, and then everybody can go back into their rooms now. How are we getting on in here?
I'm just trying to work through how to make it just go 10 times.
How to make it go 10 times?
Yeah.
So using a for loop?
For loop, okay.
Yeah. if anyone wants to share their screen, we can have a little look through it if you want to. Or keep working for a little bit if you want to have a bit more time.
Yeah, maybe in a bit. Just getting started at the moment.
Yeah, that's fine.
Thanks.
Sometimes mentally structuring it is the hardest part.
Does anyone want to share their screen if they're working towards it? I've got something, but I'm doing something wrong.
I'm just trying to catch up from this morning, to be honest, so I'm happy with anybody else who wants to do that.
If anyone thinks they have it, I'm happy for them to share. Otherwise, we can work through what I've done incorrectly.
I've got some of it. I can share, and you can have a look and see if you've got any more or.
Sure.
Yeah, let's just have a go. So I've got some of it. I've got the score, but I need to put in what is it that's missing? So asking the player if they want to play again. Oh no, I haven't users guesses. I've installed them in a list yet. Crikey, yeah, it's quite a bit more than I thought going on. So it's yeah, I need to do something that has.
Yeah, I think you got farther than I did, so give me a second. Do we also need to say too high and too low?
Oh yeah. Yeah, that's right. Oh, CAC. I think I should have done.
Yeah, it's
more in there.
So we've got the random number between 1 and 100. Got the score and an empty list.
Yeah, and then I think if I change it to else, I can just change this just to do it so that the bit above getting it right can stay.
Yeah, so start with getting it right and then.
So I think that's okay, and then the else, if it's wrong, then I can sort of change it from there. So like.
Can we do else and then if, or do we just do another if?
You do elif. Yeah, elif.
Elif, okay.
User guess less than random number. Random number. Oh, have I done that wrong? I do need to have
Is there not a space between smaller than and random number? I'm not sure I've got an idea.
Yeah, I think that's it. Okay, there. So if the user gets what's he saying? So that's too low.
Yes. So you can get it to go around 10 times.
Yeah.
But then once it's reached 10 times, rather than just leaving it, how do we?
Yeah, I'm not sure how to now get it to say you lose when you get that far, just using that
Yeah.
for loop. Because I would have done it a bit differently. In the other exercise, I was doing it as like you start with a counter of you have number of guesses equals 10, and then for every
Yeah.
guess it does that -1, so that when that gets to 0, then it prints something. It prints you lose or something. But I suppose I could. So for x I could have that as well. So have number of remaining. Oops. Oh, yeah, that is right. Remaining guesses equals 10. And then just stick it in here. I think.
Yeah.
Long variable names. Yeah, how to do it so that it's when that gets to 0. And you can, I think that's a separate thing. Oh shit, what did I do? Oh, no, I know I did. There you go. Yes. something like that. Or oh, there you go. Oh no, yeah, I can't put that down there.
Oh, yeah, you just have to say. Hmm. Okay, I think I have something that does most of it until getting the list.
Oh yeah.
Can I share?
Yeah. Yeah.
So just have it so we can check the score. I haven't tried doing 10 wrong guesses, so if we just run it, so it's 75. One, two, six. Okay. Does that make sense what I've done so far?
Yeah, yeah, it looks right, yeah.
I just did a count upwards for number of guesses.
Okay, yeah.
So I don't know if, well, I've done it a little bit different, but I've put like a while loop for saying while score doesn't equal 0.
Oh yeah.
And after each guess, you can just put like score equals score minus 100. I think
That's a good idea.
And then you like once it hits 0, it will jump out, and then you can just put like game over.
So rather than saying, so while score is greater than 0, and you do score minus 100. Okay.
Need the little F in that bit.
Yeah.
Oh yeah, got it. Yeah.
I'm gonna do it a little separately. I mean for where to do that. Or is it saying the unexpected indent? Oh. I think I'm doing this last part wrong, but I just need to check my notes about. Unless anyone remembers how to do it, so it's just a list sort of down instead of printing it in brackets.
It's not square brackets, I don't think, for there. I don't know, maybe. Or yeah, maybe, I can't remember. Let me have a look again.
I don't think you need to flip over. I think you can just, if you put a squirrely bracket and just put the name of your list, I think it just prints the whole thing out. Unless you wanted it to print on like separate lines. If you put user guest list in like squirrely lines, it should grab it for you. You're just missing a T off your user guest list at the bottom.
Yeah, we've got a T instead of an S.
Yeah, or that way, yeah.
I don't know how long I've been on mute. I just realized, but I'm going to stop share. Did I stop sharing?
You stopped sharing, yeah.
I did. Okay. Yeah. I'm just going to try to figure out that last little bit because it just keeps printing my last line and not the actual game.
Okay, I think I've nearly got it. I've just got to do the high score part of it, like checking against the high score.
Yeah.
How are you getting it to go back? And so I'm struggling with the asking if you want to play again and then going back to the start again. I assume it's a while loop somewhere, but I can't quite get it.
Yeah. Is that part of it that you have to go back?
So at the end it says ask if you want to play again, and if they do, then presumably we'll go back and start again.
Yeah, I suppose. Oh yeah, I didn't do that. No, no point.
Oh.
No, I didn't have that in there. I assumed. Yeah, they didn't. Oh, yeah, I didn't need that in there. No, okay, forget that then. For that one, if they want to play again, could that be done with something like while something equals true or equals false, and then it just sets it back?
Yeah, so that's what I'm trying to do. I'm not doing it right, I think, is the issue. But yeah, I'm setting something that's true at the start and saying while play again is true, then do the game. Then it goes through the game, and I just need to stick something in the L at the end, I think, saying, I don't know if I do. Shall I share what I've got? Will that help?
Yeah, go ahead, yeah.
Okay. You see that?
Yeah, just like, yeah.
So I'm scrolling a bit down the bottom, so I'll just put a thing in there to say, wow, play again true, and then while it's true, do the game thing, which is all of this stuff.
Yeah.
And then at the end, I want to ask a question, and if they say yes, then we set play again as true, we'll go again, otherwise it's false.
Okay, how are we getting on?
And I'm kind of stuck there, I guess. It might just be an indent thing, I'm not really sure.
Which bit isn't working? Is it just
So
it
just seems to carry on playing regardless.
Okay.
So if you look down here, so it's correct, but then it asks me to guess another number.
Okay.
Hang on, let me just see why that is. So while play again equals true, else play, do you want to play again? Oh, right. Highlight the last whole section there. Highlight, yeah. You know what's happened? You've come out of that while loop. You've just got to watch this with your loops. So your while play again equals true. Everything that's inside that while loop needs to be indented.
I wondered if it was, I kept trying to kind of do this.
Yeah, so highlight the whole lot, everything from there. Oh, yeah.
And then it goes like that. And
get it back where it was, yeah. And now highlight everything from if down.
that.
And now press the tab key, and that should indent it nicely, hopefully. Yep. So let me just see if that looks right. Check. So you want just make sure you've got everything in the loops you need it to be in. So if score exactly equals 0, print you lose. And that's fine. Your score is okay. That looks like that should work. And then check equals input. Do you want to play again? Yes, no. If check exactly equals yes, play again equals true. So it'll go again. Yeah, try that. See if that works.
Got a cross there, so it's gonna get upset about something.
Yeah, is it? Oh, you've crashed that. No, that's what does that say? Undefined name, why? Oh, it needs to be in quotations.
Oh, of course it does. Ah, hang on. It's there we go.
Good.
Ah, okay. That seems to work all right.
Fantastic. Well done. That's amazing.
Brilliant. Thank you.
Okay.
Right. I'll stop sharing now.
You better go and have your break now.
Oh, yeah.
I'm assuming we're all here and all good to go. I've been going around the breakout rooms and I'm really amazed by how well you're all doing, actually. It's been like really good work. I think most of you did get to the end of it, if not all of you. So we can go through the solution. Let's see. Okay. Can we see that okay? Someone say yes, and then I can.
Yeah.
Thank you so much. Okay. Right. So I think most of you did something very similar here to what Dan did. So obviously importing the random library. At the beginning, you need to set the high score to 0 because during the game that will get updated as long as you keep playing the game. Continue play equals true so that you can have the option of carrying on playing after you've completed the game. So the whole thing's set inside this while loop. So while continue play is exactly equal to true. Hi, welcome to the game. I'm the computer thinking of a number between 1 and 100. Can you guess what I'm thinking of? And then it selects that number between 1 and 100. And then you're setting some variables there. The number of guesses where here is set to 10, which is going to get called in the for loop, or you could just hard code it into the for loop there. Correctly guessed equals false. Set this score to start with to 1,000, and then there's an empty list here, which is going to store the list of guesses. So within the for loop, it's now going to play the game. Put in a guess number, and then it'll append those guesses here. And I think most of you got that done as well to this list called list of guesses here. If it exactly equals the number that the computer's thought of, then it'll say, great, well done, you scored, and it'll give you your score. Here are your list of guesses. So it'll call up that list of guesses for you. And then it will change correctly guessed to true. And then we'll drop out of this loop here. So break. Else if it's not correctly guessed, someone coming in, if it's not correctly guessed, oh, hang on, I've lost you. Oh my God, did I just try? Oh no, we're still here, thank goodness. Can you still see okay?
Yeah.
Okay, so else if it's less than the computer number, too low, and then this little thing here, which is the equivalent to saying score equals score minus 100. Else if, or else if it's too high, the same thing. And then it will keep going through its 10 guesses in that case. And then at the end of its 10 guesses, then it needs to know what to do now. So if correctly guessed equals false, so you didn't get the answer correct, then you lose, and here are your list of guesses. And then it's going to calculate the score. So if your score is greater than the high score, so remember the score is changing here within the for loop, then it'll give you what your score is, and then yeah, here high score changes to score. So within the game now, that number is going to get changed as long as you keep on playing. Do you want to play again? Yes or no? If your answer is yes, then continue play, and then continue play equals false if you don't say yes, if you know what I mean. So then you break out of that and you finish the game. So I think pretty much you all got exactly that. So it was looking pretty good. Does anyone have any questions on that? I think some of you spent a bit of time adding some extra nice things in there. I saw some people putting exception errors in and all sorts of nice things as well, and some additional stuff. So it did look like there's some good stuff going on. So I think I'm correct in saying that the final part of the day, let me just check, is a group coding competition. So this is just putting together all of the stuff that you've been taught using all of these. So this is everything that Dan's been through today. So now in groups, you're going to design and build a computer program that uses some or all of the concepts that you've learned about today. It can be anything you like. So some, create some sort of game or some sort of anything you like that's creative and fun. You've got 40 minutes to design and build your program. And then at the end, each group will have 2 minutes to present. And as I'm the only Pen Core judge here, then I'll have to decide the best one. No, maybe Dan's here, I don't know. There's no prize on the accolade of winning. So that's basically what's going to happen for the next 40 minutes or so. If you basically just think about everything that you've learned and just have a go at just creating something fun. And And I'll look forward to seeing what you're coming up with. I mean, given how well everyone did in the last exercise, I think you could come up with some quite cool stuff. So let's get you back again. And I think we just need to get the breakout rooms opened up again.
Print the favorites list and then do the if X.
Move that up
No,
here.
the if X equals what? Yes, down there. So just move the second if. You see what I'm saying?
This one?
Yeah. So just move it between the X and the if. Yeah, right there. And then go down because that I think.
Hi guys, I think we're all back in the main room now.
No.
Oh, looks good. I thought it was amazing. I've been going back on all of you, and you're all doing like fantastic things, really creative, interesting things. So it's looking really, really good. So Dan's volunteered to judge, which is good. And so we just need to go through now each group and get each of you to spend 2 minutes just presenting what you've done and show us your work. So why don't we start with the group that was, well, yeah, go on. Start with the group that was already going, that's in the main room.
Did you want me to share the?
Yeah, just, yeah, if you go back to sharing, then.
We weren't quite, we were trying to mess with the audit. Can you see that?
Yeah.
So in a nutshell, this was kind of like a restaurant generator to help people that are indecisive, if not everyone, with picking where to eat. So we had, you could either choose whether you wanted pizza or chicken, and it would randomly generate a pizza restaurant or a chicken restaurant, or from your favorite list, and then it allowed you to add new restaurants to your favorite list for you to go through, and would keep going until you were happy. And that was it really in a nutshell.
You want to play it for us?
Oh, I don't know if it's going to work.
Okay.
Yeah, so hopefully if you've got pizza, you get random Pizza Hut, and if you want to add a favorite, yeah, if you say yes, it should exit out. If it says no, it goes back to help you pick a new thing. And that was your lot.
That's great. That's really cool. Thank you very much. Okay, should we go deep thought? Someone from deep thought?
I'm happy
yeah.
to present. Do you want to share your screen?
Yes, give me standby caller. Hang on. Can you see that okay?
Yes. Yeah.
So basically we decided to address the Monty Hall paradox, apparently. I've never heard of, but was educated in. We had slight delusions of grandeur because it actually created a language dictionary, which would essentially insert dynamically these stock phrases in the language that the user chose, but we didn't actually get around to implementing it. So what we actually did is we just implemented the game logic. So you can play multiple rounds, and basically you get a little bit of text telling you that you're being in a game show hosted by Monty Hall, and there are 3 doors. You have to choose a door from 1, 2, or 3. Monty will then he will open a door which always has a goat behind it. So there's a bit of logic just to work out which door out of, because obviously they won't show you your door, and so it has to then look at the other doors and select the one that doesn't have the car behind it. Unless they're both goats, of course, then it doesn't matter. It just chooses the first goat-laden door. You then get the option to change your mind. If you do change your mind, then we have to do, again, a bit of logic just to swap around to work out which door is left from the choices. There may only be one. Sometimes there's 2 if you've chosen the car already, for example. No, there's always one. I can't remember. Anyway, trust me, it works a treat. And obviously, if your choice is the one with the car door behind it, then you get the congratulations, you've won a car. Frankly, much more fun is if you don't win, you get congratulations, you've won a goat, and you get a little ASCII goat as a little treat. And then you get the option to play again. So shall I run it? And then I don't know how easy it is to see, but anyway, let's have a look. The problem is I can't actually see that because there we go. Right. Okay, so you get to choose a door. Get door number 1. Monty Hall, he opens door number 2, which has a goat on, and then we got a choice. What do we think, gang? Do we want to stick with our choice, or do we want to change the door?
Always change.
Always. Oh, okay, right. Okay, so we're going to change, and we've won a car.
Oh.
So should we give it another go? Okay, so same again. 1, 2, or 3.
2.
Okay, so okay, he's opened door number 1. Do we want to change?
Yeah.
Yeah. Okay. We've won a goat. Aren't we great? And that, in a nutshell, is ours.
Very nice. Okay, can we have Hell 9000?
Yep, I'll just grab my screen. Someone let me know if you can see that.
Yeah.
Yeah.
Cool. So we tried to make Hangman, but without the man. So we gave everyone 10 lives to start with instead of trying to figure out how we would build a man, basically. Sorry, my screen has got really small text as well. I don't know how clear that actually is to see. So yeah, I'll just run it, and then we didn't get very far, but it works generally. So you're told that there are 8 letters in this word, and you've got 10 lives. To end the game early, you can type end, but please choose a letter for this 8-letter word if someone would like to choose a letter.
A.
So the word does not contain that letter. If you'd like to try again, you've got 9 lives remaining.
P.
P. So it says yippee. The letter P is in this word in position 1, and you get a list of all of your correctly guessed letters as well. So you've got 9 lives left, and we can keep going. If you want to pick another letter.
D.
A.
We've done A. I think I heard a D. Maybe go for D. So that's also correct. That is in position 8. I'm guessing you can see the word on the left. It does eventually spell out pen cord, and that is about as far as we've got.
That's fantastic.
I'm just going to type end.
Yeah, we didn't get onto the random aspect of the word.
Yeah.
Right.
Really good.
Yeah, that's it.
Okay, should we have Holly up?
I think we're going to do a double act. Mel's going to show her screen, I think, and we may get ambitious and do a little bit of coding on the go. Oh, no, it's okay. You've changed it already. Yeah. I'll tell you, can you just, it will be a bit of a risk here, but the bottom 2 lines, can you copy them? And then after where it says suspects equals suspects 2, further up, just paste them there as well. Cool. All right. So we spent a bit too long thinking about what the game should be instead of actually coding it. But we decided instead of the user playing a game, we're going to make the computer play a game. So it's a kind of Cluedo-y kind of game. So the user decides who the murderer is first, and the computer has to guess. And so we only got as far as 2 questions. We're going to ask, the computer's also going to ask questions like, is the murderer taller than 1.50 m or short and stuff like that? But we didn't get quite that far. But if we play it, I said, does the murderer wear glasses? So if we say yes, then the computer thinks, right, okay, well, Alex doesn't wear glasses, and Alice doesn't wear glasses, and Ty doesn't wear glasses. So they can't be the suspect. They can't be the murderer. So it's looking in the dictionary for glasses to see who wears glasses and who doesn't. And then it takes its suspect list and says, right, well, they aren't, they can't be the murderer. So it takes them out of the suspect list, and it tells you who's still a suspect. So then it asks you, is the murderer male or not? So if we say, because I've already picked in my head that the murderer is Mel, So if we say no, the murderer is not male, it knows, okay, it can't be Andy, Julio. It can only be Ben or Mel. Why is that? Okay, we must have a bug in our code there. And we were going to add more questions, and the computer was going to keep checking how many suspects there are. And once it's down to one suspect, it would say, aha, the murderer is whoever. And obviously we would have done the bit about multiple playing games and having a high score and a leader's board and all that, but we thought, yeah, we knew how to do that, so we'd leave that for another time.
Yeah, fantastic. That was, I like this. It's really good work. Okay, we've got master control room.
Hello, you share my screen. I don't know why it's not doing it. Can you see that now?
Nearly, yes.
So we chose to do snakes and ladders. So obviously the person starts at the start of the board, and then they roll the dice. It counts the number of times they've rolled, so it can tell them at the end. Tells them what number they've rolled, and then it checks if they've landed on a snake, which is in the snake positions list. Tells them, oh no, you've landed on a snake, and then halves their position, which obviously the further on, the meaner it gets. And then the same with ladders, except we did a dictionary for the ladders. That shouldn't be there. To say like how many numbered positions it adds to your position. And then if you get to greater than or equal to 100, you've won, and it comes out of the loop. If you're still under 100, it asks you if you want to roll again. If you don't want to roll again, then it just quits. If I play it.
Love it. I do really like that. Okay.
So we've rolled a 2, so we're at square 2. Roll again.
Oh, sorry, no, you keep going, yeah.
Sorry. Sometimes it can be a bit annoying if you don't land on anything. Hopefully we'll land on something. Oh yeah, so we got a ladder then. So we've jumped up to 74. And then that's it. We got to the end and we won. And obviously we were going to build more like squares into it to do different things.
Fantastic. I really like that. I think that's really nice. Okay, we're up to, where are we up to? Was that master control? Or Max? No, Max is next.
Hi, sorry, got to unmute. Yeah, we also did Pythons and ladders. So we have very similar. We did our snakes and ladders in the same dictionary, and we also did we did one dice roll, single dice roll, and we did the first 6 as all ladders, so we could do some testing to begin with. And ours just runs a fixed number of turns.
I think you might be sharing the wrong screen.
Which one? Is that right?
Yeah, that's it.
Okay. So so we did our implemented our snakes and ladders in the same dictionary, and we had logic in our codes to work out whether we'd gone down a snake or up a ladder. And when I played snakes and ladders with my siblings, we always had this rule where if you went over 100, you had to roll exactly to get to 100. So you had to go back the same number of spaces you'd come. So not that I'm bitter about this 35 years on, but we had to implement this. So this just takes you, so if you roll and you land on 103, you have to go back to 97, so reflecting back your 100. And ours runs for a fixed number of turns, and we usually get to the end of the game. And you can see here in this run, we had to roll exactly a 1 to get to the end, and we had to do it 3 times in the sibling rule. So that's how.
Fabulous. I think that's an important little addition. Okay, we've got Robocop.
Bear with what I share. So we made rock, paper, scissors. I'll demo first. So basically it just asks you for your input, and then decides what the computer's picking, checks whether you won or lost, and then keep score. And then you can keep going, and it will keep the score going for you until you want to finish. But to be fair, this was quite similar, I think, to the previous one we'd done, because we were a little stuck for ideas. So I've sort of done this similar conditional logic, just getting it to check whether or not you've won or lost based on defining, you know, scissors cutting paper and paper covering rock and that kind of stuff. Yeah, I'm not sure there's that much demo. I think it's quite straightforward, but we were going to try and add in like a best of 3, but we didn't think we had time for that. I don't think we would have been able to finish it, to be fair, but yeah.
Good, it's really nice work. I like that a lot. I like that you're keeping score as well. Okay, so Saint people. Saint number 5. I've got it.
Yeah, I can. Hello, I can share. Give me a second. Okay. So ours is. Can you hear me and see everything? Yeah.
Yes, absolutely fine.
Okay, so it's based on noughts and crosses, but using numbers 1 to 9 to give a score of, well, 15, you win basically. So when you sum them, so I'll play it first so you can see how it does. So it takes a second. It's not over my computer. Okay, so pick a number from 1 to 9. So so the player picks something. So pick 1. The computer then picks something, and it's showing you the remaining numbers. And it's actually showing what the computer's selected and what I've selected. So the computer selected 2. Then the remaining, so from the remaining numbers, I'm going to pick 3. The computer's picked. So I picked 1 and 3. The computer's picked 2 and 9. Pick 5. So I've got 1, 3, and 5. Is that right? Yeah. And then essentially what happens is the remaining number gets allocated to the player, but in this case the computer's won. So if I just quickly go through our code, we've put this selection in as our 1 to 9. We've created lists for the player and the computer. Glenn came up with the winning combinations here, so he's put those all in there. And then it loops around basically, so taking it in turns between the player and the computer, printing human wins when the player gets one of the winning selections, and the same when the computer wins. Yeah, and then if nobody actually wins, it will print nobody wins as well at the end.
I'm being complimentary on mute. That looks really, really good. Well done. And I think, are we at the last one? No, second last, Skynet.
Yeah, hello. We did like a lottery bingo card. Can you see my screen?
Yes.
Yeah. So we set the prizes based on how many matches that you got. We set an empty bingo card, empty winning numbers, and then we gave the user the choice of if they wanted to select their own. So if they did, then it would be an input list, and if they didn't, then we would randomly select. We only did 1 to 20 because we got more wins that way than doing by 100. And then we did basically the same function to create winning numbers, and then we compared them and then used the dictionary to look up. So if I say I want it to select it for me, so I don't want to put my own numbers, it selects numbers and then selects my numbers, tells me how many overlap, and then it pulls out the prize. And if I say yes, then it does that. We realized there's overlap of the numbers, and we need to sort that, but yeah, we didn't have time. That's it.
Really neat, well done. Such nice work here. And I think finally is Talkie Toaster.
I'll just share the screen. Is that coming through?
Yeah.
Great. Unfortunately, we didn't finish ours. So if I talk you through where we got to, it's quite similar to Andrew's from. We were trying to make Guess Who, and we wanted it to be of ourselves in the group today. So our was the computer would randomly choose one of us, and then we would be trying to play against the computer to guess which one of us it's chosen. So that's where what this is doing is it's selecting one of the group. And then each time, yeah, we started off the sort of plan was we'd have a dictionary to start with glasses dictionary, and it'd ask us, do we think the person wears glasses, yes or no? We'd type true or false, and then it'd whittle down from our starting list of names, and it would populate the glasses list with those people that do or don't, depending on our answer. But there's an error in this section, so it'll do it correctly if they have got glasses. It currently isn't if they haven't got glasses. But then once we'd cracked that, our sort of plan would be the logic would play through consistently. So we'd just repeat this loop and iterate over a reducing list each time for different features. So long hair, different yes, no type questions, until you'd have one person left in the list, and then the computer would say, is it so-and-so? Or no, we would say, is it so-and-so? So yeah, so we've not quite finished it because I think we spent a bit of a time trying to think through a project. Initially we had a more complicated one, and then we came to this one. And in hindsight, it's probably also still a bit too complicated, but it was yeah, good exercise. It was useful.
Yeah, it's a great idea, and it's good to think through how to approach these things as well. I think everyone's done amazing work, like really. I want to play all of them. I'm going to hand over to the judge, who I'm guessing will judge in the chat, because I wouldn't know what to choose, to be honest. Basic breath. Yeah. 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 We have to make the noise because Dan can't. Well done. I think honestly, well done to everyone. That was like really creative, excellent use of what you've learned already and putting it into practice. So amazing. lots of chat going on. Okay, I think a few of you have left already, and those who haven't need to get away. So we'll sign off. But great work, everyone, today. And yeah, sorry, it was a little bit ad hoc from the Alison side of things, but I think it all went really, really well. So we'll see you all next time.
Thanks.
Thank you.
Bye.
Get well soon.
Bye.